A very warm good morning to all of you. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. We shall be starting in a couple of moments, guys. Chandu, is asthenosphere a part of lithosphere? No. If not, then it is located in above upper mantle, where lithosphere is a combination of crust and upper mantle. Please understand, when we say upper mantle, what are we referring to? This is a question that I took during the live session also. Basically, what is it that we refer to as upper mantle? So if we consider this as the region of the crust, Chandu, pay attention here, and then let's suppose this is your region of the crust, then above that you have the solid upper mantle, and then you have asthenosphere, and then you have the rest of the mantle. If let's suppose this is your asthenosphere, now it is at a depth of around 150 to 400 kilometers, right? Let's suppose 160 to 400 kilometers. That is the depth. But above that, you have solid upper mantle, and above that, you also have the crust. So this region that you consider, that is your lithosphere. Okay. So even this portion will be referred to as upper mantle. Even asthenosphere can be referred to as upper mantle, because mantle, the thickness is around 3000 kilometers. So thereby you can think about that upper mantle won't be the case that only, okay, above 150 kilometers only you consider them upper mantle, rest of them you don't. So that is the case of lithosphere and asthenosphere. Okay. Ziba, how the cracks between two plates had been created only because of convection current or anything else as well? So while Ziba, convection current is one of the most important factor why sometimes the plates get broken into two, cracks get created. But sometimes what also happens, as we talked about in the case of the transform movement, where let's suppose a larger plate is supposed to move, and the northern part of it is moving at a different speed, the southern part of it is moving at a different speed, then in between the plate itself you will have a crack which will develop. I will show you as we move ahead that how, when we talk about these transform faults and the transform plates, I'll show you how the other ways the cracks can develop, but mostly it is because of convection current. Vishwajit, how gases were present inside the earth which further became clouds? So whenever you consider any particular solid compound such as CaCO3, Fe2O3, Fe3O4, any different kind of solid compound that you consider, when you raise its temperature, when you bring it to the molten state, then while the iron in it or the aluminium in it or the silicon in it, it will melt into liquid. But what about the oxygen and the carbon dioxide, etc., which is present in that compound? That will be converted into gases. So that is the way, or that is the manner in which the gases get created and get trapped in the interior. Subramania, both continental crust and oceanic crust together divided into tectonic plates? Yes, Subramania, correct. Uh, Preeti, is the height of Himachal and Himadri constant, and the height of only Shivalik increases? No. All the three of them, they keep on getting compressed and their height cumulatively keeps on increasing. Okay. Kartikeshwar, basically the convection current, when you talk about the convection current, it is that part of heat transfer, that method of heat transfer in which you have the movement of particles. So generally when you heat up water in a utensil or milk in a utensil, what you see as the method of heat transfer from the lower portion of the utensil to the upper portion, that is by the process of convection, where the water will get heated up at the lower portion, will rise up, that heat will be distributed to the top areas, and in the meanwhile the colder part of water which has remained on top, it will sink and replace the portion which has risen up. So this entire circulation is what is a convection current. Okay. In many continental divergent, we don't see volcanic activities. So, because initially you don't necessarily have to observe a volcanic activity in that case, in the case of divergence. And only after rifting has been created, a significant amount of weakening of the crust has happened, then you can have volcanic eruptions. For example, Mount Kilimanjaro, which is situated, Mount Kilimanjaro is the case of volcanic mountain, and that is present across the East African Rift Valley. Fuji plate is written in NCRT, but I have not found any image. So it is a very minor plate out there, very close to the island. It is a very small plate. It is said to have been an old, ancient, earlier part of the Pacific plate, but supposed to have been broken. So that is something which is present there. Upper mantle and crust together are tectonic plate. Dunesh, correct? Akshay, why Shivalik is good for tea cultivation and not the Himalayas? First of all, Akshay, Shivalik is a part of the Himalayas. Always keep that in mind. And when you talk about it, I understand the tonality of your question, that why is it that you don't find tea cultivation in the middle or the upper Himalayas? Because of the temperature required. When we come to the portion of agriculture, we'll be talking about the temperature required, the rainfall required for tea and coffee cultivation. Accordingly, you will understand. Tea doesn't grow well in particularly low temperatures. Tea requires a temperature range of close to around 22 to 28 degrees Celsius, right? So that is something which you find generally in the Shivaliks and in the lower reaches of the middle Himalayas also. That is why in certain areas of Himachal Pradesh, you'll find that. Shalu, convection current of entire mantle help in movement, or convection current asthenosphere also help in move? Both of them. Both of them. What is the difference between rift and a ridge? Rift is when you have, due to tension, a gap which is created. Ridge is where you have an uprised portion in between. Where can we find the fossils of Tethys? See, it can be found in the region of the Himalayas. Yes, Biswajit. If we say that divergent plate, then we will talk about divergence of plates. Don't worry. But yes, Shyam. Are the layers of Earth known as tectonic plates? No, Seema. Kindly take a look at the recordings. You will understand about the layering of the interior. Magnetic stripes of sea floor, rivers of Earth magnetism, how they relate. So that is because of reverse polarity and the present polarity. So magnetic field lines of the planet, we have talked about it, that the magnetic field lines of the planet keep on changing while we're studying about geomagnetism. So any a point of time when a new rock piece is created, now it gets imprinted with the present kind of magnetic field which is there. And in the meanwhile, let's suppose the magnetic field has reversed or has changed because of changes in the outer core due to the rotation. So in that case, the rocks which are formed next will have a reverse polarity. So like that, you have the different rocks having different kind of polarity. Okay, right, right. So now let's start the discussion. And yesterday we have had a discussion till the portion of formation of Himalayas. So yesterday, while we were carrying out the discussion, we initially talked about the presence of a convection current in the interior of the planet in the region of the mantle. And that is where we studied about the theory provided by Sir Arthur Holmes. Sir Arthur Holmes did provide the convection current theory, where he said that look, at the depth of the mantle, there is heat produced in certain areas. Heat which is produced as a sum product of radioactive materials being present and thermonuclear reactions being triggered in certain areas. And also, in certain cases, the residual heat which has been trapped in the interior, that also ends up transmitted being transmitted outside. So as a result of that heat, some portion of the mantle melts. We have seen that mantle is in a solid state, so some portion of the mantle melts, As that mantle melts, it tends to rise above, because molten materials being liquid, they are lighter than the solid substances. Now that molten portion of the mantle rises above, and as it rises above, the colder solid areas of the mantle, they replace the gap which has been created. And this rising portion of mantle then has a vertical component, a horizontal component, which can lead to the breaking of the ground surface, crack in the ground surface, and the horizontal movement can lead to the land in itself being pulled apart from each other. Right? So that is how strong that convection current in the interior of the mantle is. Now, yesterday we also saw that when we talked about the convection current in the mantle, it is not necessarily always going to cover the entirety of the portion of the mantle. Many of the times, even in the asthenosphere also, you have the presence of a convection current. Because in asthenosphere also you have the presence of radioactive materials which undergo thermonuclear reaction. So that is where, when you have that kind of a convection current in the asthenosphere, that also, let's suppose you have a convection current like this, that also can initiate the movement of the plates in certain direction or the other. Then we observed the seafloor spreading theory provided by Harry Hess, where Harry Hess actually postulated that, look, oceanic crust is very young as compared to the continental crust. And nowhere will you find an oceanic crust which is actually older than the oldest of the continental rocks. And based upon certain other observations, he concluded that newer crust gets created in the region of the oceans underwater, in the region of mid-oceanic ridges. That is where newer crust gets created, whereas older crust keeps on getting destroyed at the oceanic trenches. Now, here few of you have a doubt regarding what is a mid-oceanic ridge. Yesterday also in the image I had shown you what a ridge is. So ridge, when you hear about the term ridge, for example, in many parts of our country, you hear about the term ridge area. Even in Delhi, those of you who have been to Delhi or have been living in Delhi, so even in Delhi, in the region around Gurgaon, you refer to that region as the ridge area, Delhi ridge area. So what is a ridge? Ridge is a physical feature which has got a slight upliftment, right? So a physical feature which has got a raised slope, something like this. Now, if it is present underneath the oceans, that is your oceanic ridge. Now, Harry has propounded, based upon his observations of these oceanic ridges, he observed that underneath the oceanic water, these ridges are areas of active volcanism. That means frequently active volcanism happens here. So continuously you have creation of a newer crust, which is happening in the region of the mid-oceanic ridges. Whereas the older crust keeps on getting consumed by the trenches. Now, partly it was correct, but this seafloor spreading theory also had its drawbacks. For example, it did not talk about it that whether the continents in itself will also ever experience a force like this, or is it something which keeps on happening in the region of the oceans only. It also did not talk about the distribution of mid-oceanic ridges and the trenches across the globe, and is rather ambiguous about it. Now, all these different theories, starting from the continental drift theory provided by Alfred Wagner, to the convection current theory provided by Arthur Holmes, to the seafloor spreading theory provided by Harry Hess. Now, all of them have had few of the pointers which eventually indicated about the present circumstance, about what really goes on in the interior. Continental drift theory provided the idea that the continents can actually move, which was very new considering the kind of geographical thought and opinion which did exist in the early 1900s, where everybody was referred to as contractionists, that the planet is contracting in size. Now, from that concept, there was a significant departure made by Alfred Wagner when he postulated the drift theory. So that in itself had a major role to play. And then convection current, that help people understand that, okay, that can help in the movement of the land surfaces also, seafloor spreading, etc. So all of that was utilized, all of that information was utilized by scholars such as Morgan, Wilson, all of them, Parker. Now, eventually, they formulated the plate tectonic theory. It was, now, again, yesterday also I told you, plate tectonic theory was not something like this, that you have a research paper where 4 or 5 scientists have worked together and they have formulated a plate tectonic theory. No, it was the case where you had these people or many of these guys as professors, as faculties in Princeton. Princeton, I hope you have, well, have heard about the university name. Now, many of them were in Princeton. Now, they would keep on submitting their own theories about what actually happens on the Earth's surface, about the plate boundaries, about the lithospheric regions, and eventually all their work, when you take a look at it as a compilation, that formulates what is the plate tectonic theory. So, what is that plate tectonic theory? Yesterday, we looked at the fact that when we talk about the plate tectonic, so the entirety of lithosphere, which consists of the solid crust plus the upper portion of the mantle, which is solid, above the region of asthenosphere, obviously. So that is considered to be lithosphere. So the lithospheric region across the planet is divided into many different parts, just like a jigsaw puzzle, and that is known as plates based upon its size. The plates are classified into major plates and minor plates. When you consider the region of the major plates, what do we refer to as when we say major plates? So, for example, African plate. Now, it includes the region of the African continent with the surrounding oceanic areas of Atlantic also, as well as surrounding areas of the Indian Ocean also. Then, when you consider the Eurasian plate consists of the continental areas of Europe and the northern portion of Asia, right from the region around China onwards, and also the oceanic areas nearby: North American plate, South American plate, Antarctic plate, Indo Australian plate, and then you have the Pacific plate. Now, all these plates are in motion with respect to each other, not only the major plates, but as these major plates they keep on moving, many of the times the other plates they get compressed in between due to tension and compression. Many of the times they break, and there is development of small minor plates. For example, Indian plate, where you observe the present day location of India. Now, Indian plate includes the water bodies around India also. So it has got an oceanic crust also. Now, right to the east of Indian plate, you have a minor Burmese plate. Now, Burmese plate will also have an oceanic crust. Indian plate will also have an oceanic crust. It is the collision between the Indian and the Burmese plate also, where you observe the collision between the oceanic and oceanic crust, which has created the Andaman Nicobar Islands, which has created volcanic regions such as Barren Islands volcano, the only active volcano present in India. Right? So, that Burmese plate is a minor plate, which was once a part of the larger Eurasian plate. So, many of the times, these larger plates can also get broken down into smaller portions based upon the push and the pulls generated from the interior of the earth. Now, many of the times, you find a question being framed from this, and the question will be very generic. The question can be that the movement and the creation of different landforms on the surface is a resultant of, and the force or the energy which is actually responsible for all this movement is what? Nothing but the interior of the planet Earth, or the heat present in the interior of the planet Earth. What we also refer to as the residual heat, what is also the heat generated by radioactive materials present in the interior. So that is where all that force comes from, all that energy comes from the inside, right? So this is a part of the endogenic portion of the forces acting from interior. Now, once we observe that plate tectonic theory, then we basically observe that these plates, because they are on the surface, they can move only in certain directions. They can either move towards each other, they can move away from each other, or they can move parallel to each other. And Yesterday, we took a look at the plates moving towards each other. So, when the plates move towards each other, that is the convergent plate boundary. Now, that convergent plate boundary is also referred to as the destructive plate boundary or the destructive plate margin. Why? Because whenever you have a process of convergence taking place, one portion of the plate undergoes subduction. So, some part of that plate gets destroyed. Hence, it is convergent plate boundary and destructive plate margin. Now, there are three types of convergences: oceanic oceanic, oceanic continental, and continental continental. Now, there in the case of the oceanic convergence, we saw that oceanic convergence is always accompanied by earthquakes as well as volcanoes, something that you observe happening all around the region of Pacific. That is why the region surrounding the Pacific is also what is referred to as the Pacific Ring of Fire, because there is either oceanic continental convergence happening, as is the case with the Nazca plate and the South American plate, as is the case with the Eurasian plate and the Pacific plate, or you have oceanic oceanic convergence. For example, the Filipino Sea plate and the Pacific plate, which creates thousands of islands in the region of Indonesia and Philippines. Right? So that is why the region around Pacific experiences a series of volcanic eruptions and a series of earthquakes, what is referred to as the Pacific Ring of Fire. Now, then we also observed that basically, whenever you have continental continental convergence, you don't experience volcanic eruption. And that is because, in the case of continental convergence, first of all, so many materials along with water, etc., they don't go that deep underground, right? And unlike in the case of oceanic convergence, where you have the water also which seeps underground, that is something which is not observed in the case of the continental convergence. And that is why you have lesser number of molten materials which are present. And secondly, continental convergences crushes the rocks, creates the metamorphosis, and creates the hardened rock structure. The crust gets thickened and hardened. So that is why even the molten materials don't have the ability to penetrate through the rock system. So that is why the region of Himalayas never experiences volcanic eruption. It might experience a volcanic eruption eventually, you never know, because of a development of a deep crack or something, but it will never experience a volcanic eruption because the crust is so very thick, it is so very hard that the molten materials, they won't be able to break through it. And secondly, you don't have enough molten materials along with gases in the first place, because the situation is not like an oceanic convergence. Now, based upon these parameters, we also try to understand the formation of Himalayas, where we observed that the Indian plate, when it separated from the region of Gondwana land close to around more than 150 million years back, that is when these plates, they started moving northwards, and that Indian plate moved with significant speed. So initially it forced the Tethys Sea into subduction on the side of the Eurasian plate, also on the side of the Indian plate also. And as the compression or as the movement of Indian plate continued, eventually the Tethys Sea could not subduct at the same rate, and the region of the Tethyan Sea floor was basically upfolded, upthrown. And eventually the convergences, they led to the creation of the Himalayas. And then we also looked at the mechanism, how different ranges of the Himalayas were created. And we also looked at the basics of why is it that you experience so many earthquakes in Himalayas, and in which areas of the Himalayas do you experience these earthquakes. So those are the factors that we studied, and those are the phenomena that we studied yesterday. Now, yesterday also I told you that if you pay attention to this part, remaining portions of geomorphology, especially earthquakes, volcanoes, etc., that we are going to cover today, that is a general successor to it, natural successor to it. It is a natural evolution from that process, right? Because yesterday what we studied was that when the plates, they end up moving or rubbing against each other, you have kilometers thick rocks which are rubbing against each other. Now that movement is never going to be smooth. That movement is not only going to be very, very rough, it is going to be staggered at the same time. So you will have, as the various different plates, they try to move with respect to each other, there will be some sudden movement which shall be initiated. And that is what releases a lot of energy, huge amount of energy. And that is what leads to the shaking of the Earth's surface. That is what generates volcanoes. So today, we shall basically be carrying out that process of discussion further ahead. And we shall be moving into the portion of the divergent plate boundaries, the transform plate boundaries, and then eventually we shall be moving ahead into the region of earthquakes and volcanoes. Now, I understand many of you have various different doubts. I do try to take as many doubts as possible, as much as possible. Obviously, all the doubts cannot be considered by me immediately. That is why we have the subject matter experts. Generally, I will try to address each different kinds of doubt which are there. But many of you, due to maybe some issue or the other, due to busy time schedule, etc., you have missed out certain of the previous classes. So that is what gives you a kind of an inability to grasp certain basic terms such as the interior structure, what is referred to as a plate, etc. So for all those of you, I would recommend, rather than urging the entire session to go back to module 2, go back to the third module and then carry out the revision, kindly revise from the recorded videos. Okay? And then that will give you the able solution to it. Okay? Now, now we continue with the portion of the divergent plate boundaries and we move further ahead. Now, here, when we talk about divergent plate, divergent means what? Where the plates are moving away from each other. Okay, the plates are basically moving away from each other. That is what is divergence. Now, why will there be divergence? Divergence will be created if there is a convection current in the interior in any particular portion. Wherever there is a convection current which is generated, that can always tend to move the plates away or apart from each other, right? Now, if it happens underwater, you have the divergence happening along with the creation of the mid-oceanic ridges. Yesterday, we also saw that if a convection current gets into existence underneath the continents, there also the continental landmass will be pulled away from each other. There will be thinning of the crust. A water body might come in the and fill up that region, like the Red Sea or like the region of Gulf of Aden. A water body from nearby might fill up that area. And as the divergence continues, you can have a situation like the Atlantic Ocean, which is in the later stages of divergence, right? Because remember, we had studied that at one point of time, North America was joined with Europe, South America was joined with Africa. Now, the reason why they are all separate is because of divergence which is happening in the region of the Atlantic. So, whenever you have divergence, it always is because of the convection current which is generated in the interior. Now, in the case of divergence, you will observe that there is creation of a newer crust. As the materials they come to the surface, there is creation of a newer crust. Now, that creation of a newer crust basically means that something has been constructed, something has been created. That is why divergent plate boundaries, they are also what are referred to as convergent or rather constructive plate margins. There is no proper notes in PPT. Okay. So you expect me to write everything in the session, in the class, and then dictate it to you or write it down in the detailed note format, and then you will have the access to the annotations of the PPT. Will that be justified? Will that be meeting the standard, or will we still fall below the standard? So I'm not going to take your name, but basically understand that why do you have live sessions? Live sessions, is it for that entire thing to be written out? And then, so why have you ever referred to additional reading materials? Do you have the ARMs, my dear friend Shreyash? please understand, you have the recorded sessions with you. Okay, just to let you know the available resources that you have the recorded sessions with you. You have the recorded sessions of the tablet videos also along with you. That is additional source of information. Certain areas are covered. Now I understand many of you have not taken a look at the tablet recordings, but do take a look at that. You have certain very creative videos for geomorphology, etc., which has been done. That is also there. Also in PPT you will find the written portion. Here, wherever you seek that written text material, that is why we have those additional reading materials. There you will find the written definition of each and every concept, and that is how you can proceed ahead. Wherever possible, I will try to write as much as possible, but if you are asking for it, I will include more text in the PPT. But I will always maintain, regardless of whatever you can think about it, regardless of whatever your opinion about it can be, I will always maintain that for a subject like geography, if you want to have the approach of reading it and then only understanding, geography will be so very much ahead of you in many of the cases. You will be left chasing it. And many of the things that you will study, it will be forgotten. That is why in the first class itself, I told you that here we are going to take a visual approach, visualistic approach, where basically, with the help of the images, with the help of mechanism, I want you to understand the concept. And then the written portion should be done on your end also. At your end also, if it is done, more than sufficient. Okay, so I think it addresses two of the pertinent problems, that many of you don't have the book, so what should we do? So in case there in the first class also I addressed it, but I understand I will have to address it multiple number of times. So there also I had told you, if you don't have the written text material and you want a written text material, we are providing the additional reading materials. In the meanwhile, you can access the NCRTs, which is available free of charge online. You can go through the basic NCRTs 11th and 12th. That will also be your basic reference material. But then many of the things that we are going to discuss in the class is going to not be present in the NCRTs. So that is why you have the recorded lectures also. What we expect out of you is that when you revise it, kindly take up the notes, create your own notes, because what I might write, right, that will be my language. That is something that you might or might not be very comfortable with. You will forget it. So, always advisable to prepare your own notes. Okay. In that way, you can have a lasting preparation carried out also. Okay. I hope that is understood. NCRTs are available free of cost online. Okay, they are available, Mohan Raj, they are available free of cost. Don't worry. Now, constructive plate margin. So the divergent plates is basically referred to as the constructive plate margin, because here you observe the creation of a newer crust. Creation of newer crust. Book, please refer book, sir, which book we buy. Don't buy any book other than the NCRTs. If you are reading geography only for GS, no need to buy any other book. Now here, this divergent plate also creates volcanism, or volcanic activities will be created when you have the creation of a newer crust. When you have, let's suppose, a plate here, and when you consider another plate here, right? And again, when we say plate, we refer to the region of the crust also, and the solid part of the upper mantle also. Now here, if there is divergence, it is because of the convection current. But if I break this convection current further down, what do I get? If I break this convection current further down, basically, it will have a vertical component. It will have a horizontal component as well. Now, while the horizontal component of the convection current is responsible for pushing these plates away from each other, but as the plates are pushed away, molten materials will be injected by the vertical component of the convection current, right? So that is why here you will experience volcanism. Will we experience earthquakes here? So in divergence, you do experience minor earthquakes. So in the case of divergence, minor earthquakes are observed. Okay. So minor earthquakes, what do we mean by minor earthquakes? We'll talk about the classification of earthquakes very shortly as we move into the next module. But minor earthquakes basically which are not very powerful, which are not very strong. In the case of convergent plates, we observed that the earthquakes observed or experienced are very strong because the rocks they are pushing into each other. In the case of divergence, when the plates themselves are trying to move away from each other, now sometimes you have the molten materials which tries to rise in a large bulk or in a large mass. So as it tries to emerge, right? So it starts or keeps on shaking the earth's surface. You have a lot of molten materials which try to come up, and all those materials they keep on pushing on the earth's surface. That is when you experience earthquakes or shaking of the earth's surface. For example, for the past 3 to 4 days, I'm sure you would have followed the news. For the past 3 to 4 days, Iceland has been experiencing continuous earthquakes, right? Certain areas. Now, Iceland is at the region of the mid Atlantic ridge, exactly bang in the middle of the mid Atlantic ridge. Now, there is divergence which is happening underneath the Atlantic. It is because of that divergence that Iceland experiences so many volcanoes. And right now, Iceland is experiencing, it has been reported that in the past 3 to 4 days, there have been 800 or 900 reported instances of earthquakes or shaking of the earth's surface. Imagine, within 4 days, 900 such events. But then, they are never so strong. That tells you what? That as the land in itself is trying to drift apart, there is a lot of molten material which is trying to come up and break through the surface. Its inability to break through the surface is leading to the shaking of the earth's surface. So when you have these divergent plates created over the continental areas, for example in the region of the African continent, we experience that divergence. Now in that case, you will have the land pulling away from each other, creating very long rift valleys. What are rift valleys? Now, rift, I hope we understand the English terminology of rift. English terminology or are what? What is the meaning of rift? Some tension, right? Pulling action. So that tensional force, which induces a kind of a depression or depressed structure created due to the tensional force, a rift valley, right? We will study later furthermore about how these rift valleys exactly get created, what is the formation of the fault, etc. But then these rift valleys are present in the region of Africa. Now, that shows you that there is some convergence, there is some amount of convection current interior. Now, Africa also, by the way, indicates the presence of divergence happening in the region around Red Sea, around the region of the Gulf of Aden. So there also you have divergence happening. That is why water has entered into that area. And slowly and steadily, that divergence ends up creating a water body in between. For example, what we observe in the case here. Here, if you observe, even this region of Red Sea, observe here, this is a plate boundary. Now, this plate boundary has not always been in existence, and a minor Arabian plate here that you consider, this Arabian plate virtually has separated from the region of Africa. That is why this portion of the Arabian Peninsula and the shape of the Horn of Africa region, this portion is referred to as the Horn of Africa in the region around Djibouti, Eritrea, in that area, Somalia, that is the region of Horn of Africa. Observe the shape. Shape is similar. Shape is very same. Okay. So that is the shape that you will observe, which is very, very same. Now, that has been created because of divergence. That has been created because there's a convection current in the interior. So, that is where the divergence creates certain kinds of landforms, such as the mid-oceanic ridges. This is your mid-oceanic ridge. Observe here, this is a kind of a ridge-like portion. That is a mid-oceanic ridge. And then here you have the land areas. So in the land area, observe this is a rift valley. Now this entire large region where a large crack has been created, that is a rift valley. Okay, so observe this. This is a huge kind of a gap created, because observe these small structures. These are very large buildings, houses which are present. So with that, you can imagine the size of this depression or valley like structure. Now that has been created because the land is getting pulled away from each other. Now also, because of volcanic eruption, many of the times you also observe the creation and the formation of islands. Okay, example, Iceland. Excuse me. So Iceland has been created because of volcanic eruption which has been happening at the region of the mid-Atlantic ridge. That is what has created the island of Iceland as well. That is why Iceland experiences so frequent volcanic eruptions. Now these are your mid-oceanic areas. These are your regions of divergence. Now in all these different areas, divergence is happening at a very different rate in many of these areas. Now here, for example, this is your mid-Atlantic ridge. This is your mid-Atlantic ridge. Okay. This is the region of your mid-Atlantic ridge. So, and listen to this carefully here. The portion in the northern part here is also diverging. Here also it is diverging. Here also it is diverging. Here also it is diverging. But the divergence that you observe in the region around 1, and that might not be or is in fact different from the rate of divergence that you observed in the region around 2, because we are talking about divergence which is happening across a span of tens of thousands of kilometers. It is not a small area that we are talking about. We are talking about a very large area. So in that very large area, divergence which is happening in different areas might not happen at the same rate. So as the region of 1 and 2, both of them are moving in different direction but at different speeds. Observe, here you have the creation of a crack. Okay, here you have a creation of a crack. So then you can think about that. Here this plate is also moving in this direction. This plate is also trying to move in this direction. So that is where you have the parallel movement, transform movement. That is why it is said that transform margins or the transform boundaries, in many of the times they are perpendicular to the divergent boundaries, because this is your divergent boundary. As the plates are moving with different speed, you have the development of a crack which is perpendicular. So that is where you can observe the parallel movement also. What you observe here, this region, this is a region where, unlike the other areas of the Pacific, this is the region where there is divergence. In almost all the areas of the Pacific, there is convergence. Here you have divergence. And here you have a minor plate with the name of Nazca plate. Nazca plate. That is getting created. So here this region of divergence was the mid-Atlantic ridge. This region of divergence is referred to as the East Pacific rise or the Chilean rise. It is the East Pacific rise or the Chilean rise. Okay, it is here where you have the maximum rate of plate movement experienced anywhere across the planet. At this point of time, here, the rate of divergence is close to around 10 to 15 centimeter every year. Remember what we talked about in the initial stages of the formation of Himalayas, when the Indian plate was rushing towards the region of the Eurasian plate. Its movement was happening at a stupendous speed, significant speed of around 15 to 20 centimeter per year. Right now, majority of the plates across the world, they are moving at 1 to 2 to at max 5 centimeter per year. At the region of the East Pacific rise, there is divergence which is happening at a rate of around 15 centimeter per year. Okay, so this is the only region where the Pacific is ever so expanding. In all the other areas, the size of the Pacific is decreasing. Even here, you have convergence happening from one end of the spectrum. Okay, now then we have the transform plate boundaries. Now, transform plate boundaries are basically the boundaries or the plates where they move parallel to each other. They neither move towards each other, the plates neither move away from each other, they move parallel to each other. So in this case, neither there is a destruction of the existing crust, neither a newer crust is created. Whatever is the crust is conserved. So that is why this is also what is referred to as a conservative plate margin. Right? You have the parallel movement of plates. Okay, you have a kind of a parallel movement of the plates. Now here, why do the transform plate boundaries, or why is it that the parallel movements happen? Again, because of convection current itself. Okay, so convection current is basically responsible for all the different types of plate movements that you can think about. So this also is initiated because of the convection current. Now you can imagine, mostly by the way, what we talked about in the previous slide, that majority of the transform plate boundaries, they end up remaining perpendicular to the region of divergence. Okay, majority of transform plate margins are perpendicular to the region of divergence. Okay, why? Because across a larger divergent plate, you experience different rate of movement. So that is why it develops cracks, because of the different tension which develops because of varying rates of movement. That is why cracks develop in the existing plates. So due to different rates of movement cracks develop and a parallel movement can be observed. For example, if you observe the image here also, in this case also, if you observe, there is divergence which is happening here. Notice this carefully. There is divergence which is happening here. Now, the rate of divergence in different areas are different. So that is why observe you have a transform movement, transform boundary here, almost perpendicular. Okay, so here you have transform boundary. Here also, by the way, you have the transform movement. So many of the minor plates, for example, the Anatolian plate, which is present in the region around Turkey, it is that movement across the Anatolian plate which continues to trigger massive earthquakes in the region of Turkey. Even this year, you would have heard the news stories about Turkey experiencing very massive earthquake. That is because of the transform movement of the Anatolian plate in that region. So that is how transform movement basically ends up meaning a kind of a parallel movement with respect to each other. So that is a conservative plate margin. Now think about it. When the plates are moving parallel to each other, now there will be significant amount of resistance, obviously, because we are talking about very thick crustal portion and in fact the entire lithospheric region rubbing against each other. So it won't be a smooth process. So periodically, time and time again, as they are trying to move parallel to each other, not only will they experience that force of resistance, but as they overcome that resistance, there will be that sudden movement, right? And as they try to overcome that resistance, sometimes amongst the parallel plates, a larger cracks also might develop. Here, multiple different cracks might all develop along with the existing crack here. So these regions become areas of very active seismicity, experiencing very massive and powerful earthquakes. So here also, very massive and powerful earthquakes in these areas also. So here you will observe that the plates, they move parallel to each other, neither creating nor destroying a feature, leads to significant tension being built up and creation of earthquakes and faults. That is, faults we will study later is nothing but development of larger cracks in existence. Now, for example, here you can consider the San Andreas fault. San Andreas fault. Where? In the region of US. That is where you have the San Andreas fault. Okay. So this is basically a map which I have given here, which tells you not only the presence of the various different plates, but also their corresponding movements nearby. Okay. So the divergence. So for example, observe here, there is divergence, right? Here there is convergence and so on. Now, in the region of India, if you observe this, you will observe that it is the Indian plate which is moving, in fact, like this. So that is why the entire region of Himalayas have been created. And that is also the reason why the entire region of Himalayas, they are very prone to earthquakes. Very frequent earthquakes will happen because the plates are moving with respect to each other, against each other, and that is why, due to the force of resistance as it is offered, as they try to overcome that force of resistance, you have these earthquakes, massive earthquakes, which keep on getting generated. In the meanwhile, here, if you observe in this area, basically, you will observe the region of Gujarat. Now, the region of Gujarat experiences very heavy occurrence of earthquakes there also. If you look back at the history for the past 200 to 50 years, Gujarat, other than the region of the Himalayan foothills, Gujarat is another area which has experienced massive earthquakes. Why is it so? Because observe that the region around Gujarat lies at the plate boundary of three plates: the Indo Australian plate, the Eurasian plate, and also the minor Arabian plate. That is why any movement across any of these plates will always trigger seismic activities in the region around Gujarat. Now, here, going ahead into the future, we are going to observe the African plate going to break into two around the region of the East African Rift Valley. So, this portion of Africa will split away. That is why, for the past few thousand years, for the past few lakh years, if you consider, there has been volcanic events and creation of a rift valley in this area. Right now, The remaining portion of Africa is pushing northwards. It is pushing into the region of Mediterranean Sea. That is why in the region of Mediterranean, where you have the oceanic crust, that oceanic crust is getting subducted underneath the Eurasian plate. And this is the reason why in the region of southern Europe, that is around the Italian coastline, you find so many active volcanoes, right? You have various volcanoes such as Stromboli, Etna, etc., dormant ones such as Vesuvius, etc. Why? Why you have so many volcanoes present in the region of Mediterranean? Because as the African plate is pushing northwards, the part of the Mediterranean Sea is getting subducted underneath the Eurasian plate. So that is why you have volcanoes. Something very similar of what was experienced in the region of the Tethys Sea. It is said that going ahead into the future, you can basically formulate or postulate what will be the condition there, because we have seen the formation of Himalayas, or rather we know about the formation of Himalayas. So something very similar will happen there also. So in the coming few million years, the Mediterranean is certainly going to disappear. And also, you will find that rather than the Mediterranean, that region will be replaced by very high mountain ranges. It might turn out to be larger than the Himalayas in the next coming 100 million years or 50 million years. But that is the reason why the northern fringes of Africa, here you will find the fold mountains in the form of Atlas ranges. And it is in this area around Libya and the surrounding regions, Morocco, etc., that you experience frequent earthquakes, very frequent earthquakes. Here you experience, Italy also experiences very frequent earthquakes. Italy experiences volcanoes also, right? So, with the help of plate tectonics, not only are you able to justify why a certain landform has been created, for example, the region around this entire Southeast Asian area, that is the Indonesian and the Philippine island region. You have thousands of islands. Why? Because of oceanic convergence happening in that area. So you have these volcanic islands which keep on getting created. For example, we have this massive Indo-Australian plate, but the recent events have indicated that the rate of movement or the movement of the Indian plate or the portion of India here is slightly different from the region of the movement of Australia. So there is a crack which is developing here. So in the coming few years, this might separate altogether. You might have a different Indian plate and a different Australian plate considered altogether. But right now, Indo-Australian is still considered to be a major plate. Okay, so this is basically your entire movement which is happening. African Rift Valley is created because of divergence. Okay, and why is divergence created? Because of the presence of convection current in the interior. That is what generates the Rift Valley in the region of Africa also. Okay, African also divergence. So I think Biswajit, Poonam, your doubts would should have been resolved. Okay, right. The convergence and divergence mainly due to the circulation current is only same plate will experience both. So I hope now you get an idea that in the same plate you can experience different push and pull from different areas. It is a larger plate that you consider. So here you might experience divergence, here also you might experience divergence, here you might experience convergence, right? So you can experience different areas. Okay, now let us take a few questions here. So these are some of the easy questions. So here, which of the following phenomena might have influenced the evolution of organisms? Continental drift and glacial cycles. Which would have influenced the evolution of organisms? Anurag, the three plate boundaries on which you have on the region of Gujarat is the Arabian plate, Eurasian plate, and the Indian plate. These are the three plate boundaries. Is it because the African plate is moving apart from Arabian plate? No, Biswajit. within the African plate itself, you have a convection current which has come into play. That is why Africa is breaking into two. That is why, as the African land is breaking into two, you have the creation of Rift Valley. Yesterday, we had covered it in detail, that how you have if you have a convection current present in the interior, in the region underneath the continent, how initially the thinning of the land masses happen, and how then they start moving away. Then you have a creation of a rift valley, then eventually water starts coming in, then you have creation of an ocean. I hope you remember that discussion. So that is something which is the case. Now here majority of you have given the correct answer, and that is the both of them are responsible for the evolution of organisms. So the correct answer is both 1 and 2. Okay. Now then, which of the following pairs is or are correctly matched? You have the theory and the associated scientist who has provided that theory. So continental drift, expansion of universe, and photoelectric effect. I heard the East Coast will also experience rift. You have certain rift valleys, Dunesh, in the region around, for example, in the region around Damodar, in the region around River Narmada, and you also have a kind of a fault line escarpment across the west coast. East coast doesn't have a rift in existence. Yes, Subramania, mostly. Good. Here also, majority of you have given the correct answer. So continental drift was provided by Alfred Wagner, not by Edwin Hubble. Expansion of universe provided by Edwin Hubble, so this is also incorrect. Photoelectric effect was provided by Albert Einstein, so that is correct. Okay. Now, Ravindra Babu, that is the question that UPSC had asked. This is not a question which I had created. So in questions of UPSC, which is the closest answer? That is something that you have to come to the answer of. Okay. Now, in the structure of the planet Earth, below the mantle, the core is mainly made up of which of the following? Aluminium, chromium, iron, and silicon. So this is going to be much easier. So I don't think you need that much time window for this. So I'll give you 15 seconds. Correct option in the last question was B, Sana. Chandu sir, I read that counterclockwise movement of Indian plate going to meet Australia. No, my dear friend. See, Indian plate is as of now going to push to the north. Australia is also going to come to the north. So this is where if you, from your perspective, if I think about it, if this is India, this is Australia. So 50 million years down the line, you will have Australia somewhere in this area, right? Almost. So India will be pushing northwards, but it won't be pushing at the same rate because of Eurasian landmass. But Australia can push northwards with some amount of speed. So over the next 100 million years, 50 to 100 million years, you will have this kind of a movement where Australia comes northwards to its present location. Okay. So here again, majority of you are correct. The correct answer is C, that is iron. Okay. I hope that is understood. Now, after this, we come to the portion of earthquakes, volcanoes, faults, and faults. Now, this is a portion which is relevant both for your prelims as well as for your mains examination. Even this year, you had a question which was directly picked up from the discussion of the PPT itself, and you had such a question framed in the prelims also. So, here for the prelims, what is going to be relevant is going to be basics of earthquakes, and volcanoes. Then seismic waves and their properties. For GS, you only have to study the P and S waves. Then after that, shadow zones. Then after that, volcanic landforms. Okay. Then after that, chemical properties of magma. Then after that, intrusive volcanic landforms. Now, for the mains examination, the relevant areas are basically shadow zones of seismic waves, human induced earthquakes, or seismicity, then global distribution of earthquakes, this comes under the part of your world geography, global distribution of earthquakes, and volcanoes, and also hotspots and mantle plume. So these are the areas relevant for your prelims and mains examination. Accordingly, while you carry out the process of revision, you can pay attention and some amount of concentration into these particular areas. Sir, is NCRT is important to read after learn from PPT? No, not necessary, but just as a mode of revision, that is something that you can carry out. Okay, leaderboard. Okay, fair enough. I will show you the leaderboard. So this is the leaderboard, guys. So majority of you have given all the answers as correct, right? So that is the leaderboard. Now, as there are Chandrajyoti, as there are difference of speed between India and Australia, so there should be fault or transfer movement near Java and Sumatra. That is what I told you, Chandrajyoti, that there is a crack which is developing in the region around Indonesia, and in the coming days there will be a division or the breaking of that plate. Indian plate will be separate, Australian region will be separate. That is what we discussed some time back. Now, when we talk about earthquakes and volcanoes, these are amongst the sudden forces which act on the Earth's surface, which are experienced on the Earth's surface. And they are created or experienced on the Earth's surface, they occur on the Earth's surface because of events or energy present in the interior. Now, this also is a part of the forces which are acting from the interior of the planet. So, these forces which act from the interior of the planet, generally a sum product of the radioactive materials which are present, a sum product of the residual heat. So these forces are also what are known as the endogenic forces. Endogenic forces means forces acting from the interior. Acting from the interior of the planet. Okay, forces acting from the interior of the planet. Now, whenever you will observe that rocks they try to move with respect to each other, or Earth's surface they try to move with respect to each other, that movement is never going to be smooth. That movement is going to be experiencing a lot of resistance, because as the rocks they try to rub against each other, there is resistance which is offered. Now, some or the other time, that resistance will be overcome. And when that resistance is overcome, that leads to shaking of the ground surface. So, that shaking of the ground surface, that is what we refer to as an earthquake. So, when we say an earthquake, these are caused due to the sudden release of enormous amount of energy accumulated within the region of the planet. So, for example, if you consider these two areas, let's suppose you consider these two regions of the crust, okay, or even the lithospheric regions. If not the entirety of lithospheric region, let's consider only the crust. Now, as these rocks they try to move against each other, one part of it, as you can observe, is trying to basically move in other direction. In some or the other region, that force of resistance will be experienced. As that force of resistance is overcome, massive amount of energy is released. So, for example, if these rocks are moving, here let's suppose the knuckle of my middle finger, that is offering that force of resistance. So there, as they try to move with respect to each other, here they experience that force of resistance. And eventually, as the force of resistance is overcome here, you will have massive earthquakes which are generated. So, the region where that energy is released in the interior, that is known as the focus of the earthquake. So, whenever you talk about the focus of the earthquake, so focus refers to the region in the interior where the release of energy happens as the rocks or the crustal surface or lithosphere overcomes the force of resistance. Now, I have seen many people, they start learning these definitions, that I will learn the definition of focus, etc. And that is virtually no fault of their own. That is a legacy of the sad state of education system that we still pursue, where rote learning is always the case, that you ratify a definition, you vomit it out in the answer paper in the exam, and you will be rewarded a good marks. Now, UPSC is not like that. So here I would always suggest to all of you, not only for the subject of geography, but for the other subjects also, please don't try to learn definitions. When you learn a definition, you create a scope that you can forget some part of it or some phrase of it, and in trying to recall it, you might end up committing negative marks or mistakes thereby. So you might end up creating that. So don't learn it. Try to understand any concept and have the ability to recreate the definition, write it in your own words. Only then you can have a flexibility to fit a definition in even 15 words if required, and if required, even elaborate to 45 words or 50 words. Okay. Now, that region which is present in the interior, where that release of energy happens, that is referred to as the focus of the earthquake. Now, let's suppose the focus of an earthquake has happened, or an earthquake has occurred in your region, and the focus is 50 kilometers underground or 100 kilometers from underground from the surface. Now, how will you refer to it? How will you basically address it? That where the earthquake has occurred. You need a point of reference on the ground surface also, so that you can say that, okay, 50 kilometers below Kathmandu, that is the region of the focus, or 50 kilometers below Bhuj in Gujarat is the region of the focus. So you need a reference parameter on the ground surface in order to locate that region of earthquake. So directly above, directly perpendicular to the focus on the surface, you have the epicenter. So epicenter is basically the origin of the earthquake. Epicenter is always referred to as the origin of the earthquake. It is immediately above the region of the focus. Okay, perpendicular to the region of the focus. So basically, when an earthquake occurs, the destruction is something which spreads all over from the region of the epicenter. You would have heard the news stories that an earthquake has occurred in the region of Afghanistan with its epicenter near Kabul. Earthquake has occurred in Nepal with its epicenter near Kathmandu. So that is the epicenter. That is the surface. Okay. Now, Gujarat earthquake, which happened way back in 2001, January 2001. Now, that had its epicenter at Bhuj in Gujarat. So, like that, it is the epicenter. Now, based upon the focus, you have the classification of the earthquakes which is done or into shallow focus earthquakes, intermediate focus earthquakes, and deep focus earthquakes. So, classification based on focus. So you have shallow focus. Now, shallow focus earthquakes are those where the epicenter or where the focus will be at a depth of around 100 kilometers, right? That will be the depth of it. That is from the surface up till the depth of 100 kilometers within the lithospheric region itself. That will be the shallow focus. Okay. So this will be basically 0 to 100 kilometers. Then you have intermediate focus. So when the focus lies at a depth between 100 to 300 kilometers, so that is the intermediate focus. And then you have the deep focus. That is 300 kilometer to 700 kilometer. Now, there is no earthquake which occurs having a focus deeper than 700 kilometers. And what is the reason for it? That is because at a depth of greater than 700 kilometers in the mantle, the temperature is high, the pressure is also so very high that rather than the materials trying to overcome that resistance and still moving, the materials rather they bend and deform. So rather than overcoming the force of resistance, there will be deformity. So that is why no earthquakes beyond the depth of 700 kilometers. Now, every day, on a daily basis, planet Earth experiences hundreds of earthquakes. We only hear about one or two. Every few days, we hear that an earthquake has occurred here or there or there. We hear about very sporadic cases or events, one or two of them. But every day across the planet, you have hundreds of earthquakes which keep on happening in different areas. As the plates they try to move with respect to each other, minor or massive earthquakes are triggered. Now, that earthquake, each of them, basically, why don't we experience the hundreds of earthquakes? Because many of them, they are so very minor that we don't even feel them. We don't even feel the energy of them. For example, if I tell you that based upon the focus, if let's suppose the same amount of energy is released, in the shallow focus earthquake also, in the deep focus, in the intermediate focus also, if the same amount of energy is released, in which case will you experience maximum destruction or devastation? In the case of shallow focus earthquakes, intermediate focus, or the deep focus earthquakes, where do you experience maximum destruction? Very good. Always it will be the shallow focus earthquakes, right? Because the energy is being released very close to the surface. So that will hit the surface, that will end up shaking the surface, right? Now, the idea about earthquakes, the information about earthquakes was always present. In fact, if you take or if you find the written records of the Nepalese kingdom also, they have started mentioning the earthquakes and the records of earthquakes from around 13th century onwards. And in their records, they have talked about it, that how many of these earthquakes have led to the destruction of the entire kingdom also, because the destruction caused is so immense, so huge. Similarly, across the world, earthquakes have been reported for a very long period of time. Now, for a long period of time, mankind did not have any idea why these earthquakes are occurring. It is only in the 1900s where we started understanding these earthquakes in a greater manner. Now, initially, the earthquakes always they were to be classified. When you report something, when you maintain a log or a data for something, you have to classify it, that which kind of earthquake has occurred there, what is the amount of damage, etc. So the earliest classification of earthquake which was done based upon the damage causing potential. That suppose an earthquake has occurred, now that has led to the destruction of the buildings. The buildings have started falling. That has led to large cracks appearing on the ground surface. Lot of destruction, devastation. The trees have also fallen. The infrastructure has fallen. So basically, that is the worst kind of earthquake. Maximum devastation. There are certain earthquakes which you read it in newspaper reports, but you have not experienced that on your own. So that means earthquake was not damaging enough. So, based upon the damage causing potential, you had the intensity of earthquake, which was decided. Okay. So, whenever you talk about the intensity of an earthquake always talks about what is the impact on the ground surface, the impact that an earthquake has created. But there's a discrepancy here. What is the discrepancy? The discrepancy is that the impact on the ground surface, it is variable. It is dependent on many different factors. Okay, before that, let me write it down so that you have some aspect about it. So first thing that I will write down is, why no earthquake beyond a depth of 700 kilometers? As many of you had requested that I add a white sheet and then write it down. So this is for you guys. So why no earthquake beyond a depth of 700 kilometers? The pressure is so high that rather than the rocks rubbing against each other, right, they end up getting deformed. Okay, hence no frictional force to overcome. Then, when we talk about intensity of an earthquake, so this basically is what? That is the impact that the earthquake creates on the ground surface. That is basically the intensity of an earthquake. But as I told you, that this intensity is quite variable for that matter. This intensity is not consistent, right? So here it is dependent on many factors. For example, if you consider, let's suppose you have a region where you have an earthquake which has originated at this depth, and another region where an earthquake has originated at a greater depth. Let's suppose the energy released by both of them are the same. So the impact which will be observed here will be much higher. Damage, destruction which will be observed there will be much higher. Now, again, for example, suppose here the types of buildings that you have, they are earthquake resistant. For example, here you have buildings which are not earthquake resistant at all. So damage or impact will be visible much greater in the other ways, where you will observe all the buildings have fallen, right? None of the buildings have been able to survive. For example, in the region of Latur in Maharashtra, now you had an earthquake of close to around 5 magnitude which occurred. Now, because the condition of the buildings, the condition of the settlement was such, you had thousands of casualties because immediately all the buildings they fell down, all the buildings they basically collapsed, and you had those casualties, you had the destruction. Now, simultaneously, you will observe many areas which have withstood a 5 magnitude earthquake, right? So, if the same energy is released, damage causing potential is different. Again, another factor, for example, suppose this is a region which is made up of rocks, stable rocks. And this is an area which is made up of sedimentary floodplain. The deposits that you observe, the rivers make, for example, Delhi is on a floodplain, right? The northern Indian plains, that is a floodplain. So, floodplain basically deposits created by the river, sedimentary soil. Now, if here you have the sedimentary soil and a floodplain, and here an earthquake occurs, let's suppose at this depth. Now, here you have the rocks, the earthquake has occurred at this depth, and at the same depth, if an earthquake occurs in the region of the floodplains, the damage will be much greater in the region of the floodplains. It will be a kind of a cataclysmic event. Why? Because when you have that kind of a spread of sedimentary soil, that sedimentary soil means what? That virtually all the soil in itself will experience a kind of a wave-like undulation. And whatever structure is standing on top of it, immediately it will crumble down. So, what I'm getting at by all these factors is the same, that intensity of an earthquake is dependent on many factors. The depth of focus, the type of buildings, the type of the ground surface, all these factors, they end up influencing what is the impact that we are observing on the ground surface. So this was not a perfect criteria to classify the earthquakes, because it was understood that different regions can have different impact. So when we talk about these earthquakes, you had modern mechanism which needed to be evolved. Now, intensity of an earthquake would be classified based upon, for example, that if there is no damage, if it has not been observed by us, if there is some damage, shaking of the surface has been observed. Maybe the instruments in your room, the installations in your room, they have started shaking. In certain cases, the you have observed the floor shaking. Then, furthermore, if the impact is much more, you would have had to evacuate. You would have observed the trees also shaking. You would have observed the building shaking. Then, further more powerful earthquake means the buildings would have fallen. Further more powerful, lot of destruction, devastation. Nobody is left behind. Right? lot of casualties. So that intensity would be classified based upon these criterias. And this is what would be denoted in a Mercalli scale. So Mercalli scale basically is a classification of all these various different types of impact that you observe, not experienced by us, experienced by us but ever so lightly, experienced by us significantly, shaking of the materials in the room, then shaking of the buildings also, then destruction of the buildings, etc. Right? So intensity is classified, demarcated based upon the Mercalli scale. Now, this was done in the early 1900s. Over a period of time, different classification has been done in that impact. And for example, shaking of trees, etc., poles, etc., has been included. And now it is referred to as modified Mercalli scale. That is MMS rather than only Mercalli scale. Okay. Now, here it was understood that what you actually need to measure if you have to classify the earthquakes, you actually need to measure the amount of energy released. The amount of energy which an earthquake releases, that will give you an idea about where the rocks are moving, why they are moving, why it is releasing that much amount of energy. And it will also help you understand why that much damage is getting created in certain areas. For example, in the Himalayas, every few years, you have very massive earthquakes which happen, which flatten the region to the ground. Right? So that is why energy released by an earthquake was required to be measured. And for that, you have an instrument which is referred to as seismograph. Seismograph is one of those instruments which measures the energy released from an earthquake. So you have seismograph is basically a small instrument this big, and there, just like an ECG machine, I'm sure you would have seen ECG machines at some point of time or other. You have roll of paper and then you have a pen or a stylus which keeps on moving. So it generates a kind of a report. It generates a kind of a live system where you will observe that a pen continues to move here, right? And it keeps on detecting any movement which is happening. Any movement which is happening. So let's suppose there is that sudden spike. Sudden spike. So these are basically your earthquakes, which are measured. They measure the energy, right? So if suppose the seismograph observes these readings based upon the shaking of the surface, now you observe these variations in the graph. By measuring these variations, you get an idea about the energy released. So then we started measuring the energy released during the earthquakes and in fact the amplitude of the energy released. And that is what is referred to as the magnitude of an earthquake. So when we talk about magnitude of an earthquake, represents the amount or the amplitude of energy released during an earthquake. Amplitude of energy released during an earthquake. And what is amplitude, by the way? So for those of us who are unaware of about it, if suppose this is a kind of a wave motion, so the maximum deviation, this is your amplitude. This is your amplitude. So it gives you an idea that what level of energy might have been released. Now, this magnitude, just like intensity is something which is measured based upon the Mercalli scale, magnitude is measured based upon the parameters of the or numbering of the Richter scale. So it is measured on the Richter scale. Now, Mercalli scale, as I told you, has got its division that, okay, this much amount, the shaking of the ground surface happened, not felt by us. Shaking happened, which was felt by us. Shaking of the installations in the building, shaking of the building itself. So that is the classification of the Mercalli scale, different stages of classification. Richter scale, you have a numerological classification. So magnitude of 2, magnitude earthquake of magnitude 3, earthquake of magnitude 4, it varies up till the portion 10. Right. Now, this scale is logarithmic in nature. Logarithmic in nature. Means what? It means an earthquake of magnitude 7 will release 10 times more energy as compared to an earthquake of magnitude 6. Magnitude 6. Okay. So that is basically the case. So it is logarithmic in nature. So an earthquake of magnitude 5 will be 10 times more powerful or will release 10 times more energy as compared to earthquake of magnitude 4. An earthquake of magnitude 6 will release 10 times more energy as compared to an earthquake of magnitude 5. Right? So that is why you hear, or when you read the news story, you would have read that earthquake of magnitude 5.7 has hit this region, earthquake of magnitude 4.5 has hit this region, and so on and so forth. Okay, so this is basically the demarcation. Now, ideally, the Richter scale has got its scope to be demarcated up till 10. But then, if you take a look at the historical database of the earthquakes which have occurred, if you observe the magnitude, for example, the Gujarat earthquake, which occurred in Bhuj in Gujarat, many of you would have been very young to recall that. But it was amongst the most massive earthquakes that India has observed in the past couple of decades. Now, that was reported to have a magnitude of close to around 8. 7.9 to 8.2, because you had the US government agencies reporting it was 7.9. Later on, by analysis of the data, they came to a conclusion it was an earthquake of magnitude 7.9. We reported initially that it was an earthquake of magnitude 8.1. For example, the region of Kathmandu, the Kathmandu earthquake of 2015, April 2015, which led to the absolute demolition of the region of Kathmandu, was an earthquake of magnitude around 8. Now, Indian Ocean experienced a massive tsunami. You would have heard about it, that the eastern coast of India, it experienced massive tsunami on 26th of December 2004. Now, that was induced by an earthquake which occurred in the region around Sumatra. So, that also had a magnitude of close to around 8. Very rarely in the past 100 years or so will you ever come across an earthquake higher magnitude than 8. Right? An earthquake of magnitude higher than 8 means it will be cataclysmic. It will have endless amount of destruction and devastation. Right? An earthquake of around magnitude 7 and more, very serious. An earthquake more than 9 magnitude, unimaginable. So till now, obviously, you can think about it that we can have an estimate that an earthquake of 9 magnitude might have happened 500 years ago or 1000 years ago, but we don't know for sure, right? And obviously, earthquake close to around 10 has never been experienced. Okay, so okay, this is a very interesting question. Um, is Pokhran was also a reason for Bhuj earthquake? So when did the Pokhran blast happen? Pokhran blast happened in what year? And when did Bhuj earthquake happen? 3 years later. So basically, when you consider the region of Bhuj earthquake happened in January 2001. And why is it that Bhuj earthquake happened? We had this discussion just a few moments back. The region of Gujarat keeps on experiencing earthquakes, very frequent earthquakes. Why? Because it is at the boundary of three plates: Indian plate, Eurasian plate, and Arabian plate. Any movement across any of these plates will trigger an earthquake in Gujarat. Okay, right? Yes. Turkey, you had 7.8 in February. Logarithmic basically means the log scale you would have read in. See, I don't want to get into that entire log table and so on, but think about it how the exponential nature of it works. Basically, if you have an earthquake of, so you are measuring the amount of energy released. Now, how will you depict it on a scale if you have to restrict that scale from 1 to 10? Okay, so that is why you have basically earthquake of magnitude 7 will be 10 times more powerful than earthquake of magnitude 6. Earthquake of magnitude 8 will be 10 times more powerful as compared to earthquake of magnitude 7. So you can think about it that when you have a magnitude of 8, it is releasing almost 100 times more energy as compared to an earthquake of magnitude 6. It is releasing close to 1,000 times more energy as compared to an earthquake of magnitude 5. So that is the logarithmic nature. I'm sure, I think it would still be there in your syllabus out there, about in your school syllabus about the log table. You would have read it in your class 8th, 7th, or ninth standard. I don't remember. Okay. Now, here, this is your basic classification. Here, Mercalli scale represents the intensity of the earthquake. The range varies from 1 to 12. When we talk about the Richter scale, it represents the magnitude, and the magnitude is expressed in numbers, again from 1 to 10. Magnitude basically measures the amount of energy released by an earthquake called its magnitude, can be measured by the amplitude of the seismic waves produced. So we have seen the seismic waves. So when you measure the amplitude of these seismic waves, amplitude as in this variation, you get an idea about the variation or the amount of energy generated during the earthquake. Okay, right? You mean earthquake is extremely dangerous? Absolutely, yes. I'm sure most of you would have, at some point of time in your life or other, you would have experienced an earthquake. And I hope you recall how spooky it is. Okay, so we'll carry on further with this. We'll carry on and talk about these earthquakes more. What are these aftershocks, foreshocks of an earthquake? And then we will move ahead. We will also talk about how we humans, we also end up inducing an earthquake. It is not mercantile scale. Mercantile, I think there is an overload of history there when you're talking about mercantile. It is not mercantile scale, it is Mercalli scale. Mercalli, named after the scientist. That is the Mercalli scale. Okay. So let's take a break. And so I don't want to get into the negotiation again. We'll take a 15 minutes break and then we'll be back after the break in 15 minutes. Okay. So by around 8:02, we will carry out. Vishal, the difference between Mercalli and Richter scale, that is what we had said here. Mercalli scale represents the intensity of an earthquake. Richter scale represents the magnitude of an earthquake. Chandrajyoti, if you would have visited the northern portion of your state, you would have experienced many of these earthquakes. But nonetheless, let's convene after the break and let's continue the discussion further. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Right. So, that is what we have seen about how basically you have the classification of the earthquake and also the measurement in terms of what an earthquake actually is. Right. So when you have to measure the damage causing potential, that is a weak earthquake or not felt, only instruments are able to observe those earthquakes, etc. So that kind of a classification you do on the basis of the Mercalli scale. But if you have to classify based upon the amount of energy which is released, if you have to measure the magnitude of an earthquake, that is when you use the Richter scale. Now, I also told you that historically, we have experienced very few earthquakes which are higher than 8 in magnitude. Now, if you consider that in the past century, one of the strongest earthquakes that has ever been experienced has been in the region around Chile. In the region in the southern part of Chile, what is also referred to as Vladivian earthquake, there the magnitude recorded was close to around 9.5. Right? But these are very rare instances, very rare events. Generally, the earthquakes which you experience are lesser in magnitude and have lesser amount of energy which is released. Now, when the earthquake releases an energy or the event of an earthquake, whenever energy is released, now that energy travels in the form of waves. Any form of energy in general that you will experience, it travels in the form of waves. Energy generated during an earthquake, they are referred to as seismic waves or waves which are generated due to seismic events. Now, by the way, when we hear about the term earthquake, you also hear the associated terms foreshocks and aftershocks. Foreshocks and aftershocks. So basically, think about it. As the rocks, they are trying to move with respect to each other. Before the immediate and the major movement which will happen, there will be slight adjustment that the rocks will make in order to initiate that movement. So even that slight movement can end up shaking the surface, right? So many of the times on the seismograph, you observe a kind of a demarcation where, for example, if you observe the readings of the seismograph, initially there are slight variations, right? Now, these small variations or the shakings which are happening, that is a precursor of a major event which is about to follow. And then after that again, small variations as the rocks readjust to their newer location. Right. So these shakings or these small earthquakes that you experience before the major event, that is what is referred to as foreshock. Fore here refers to something which has happened before the main earthquake, something which has been experienced before the main earthquake. This is your main earthquake event. Event. And as that movement of the rocks have happened, after that, as the rocks they try to adjust to the newer location, to the new position, there also some amount of shaking of the surface will happen. So that is what you experience in the form of aftershocks. Right. So many of these earthquakes, for example, the 2015, April 2015 Nepal earthquake, which occurred, had its aftershocks continuing well almost up till a month, where you would experience some shaking of the earth's surface almost up till a month after that main earthquake. Now, foreshocks can happen a few weeks before the earthquake. Foreshocks can happen a couple of days before an earthquake or even few hours before an earthquake. So you don't have the exact predictability that okay, an earthquake is going to occur at 4 p.m. on 15th of November. So that kind of a predictability is not there in the case of an earthquake, because we are not very sure that when that eventual movement will be triggered, which will release that energy. We do know, we are able to calculate that where pressure is building up in the rocks, where they're trying to move but are unable to move. But we are never able to define that when exactly that resistance will be overcome, that movement will happen, or that energy will be released. That is why earthquakes are not be we are not able to predict. Now, this particular earthquake, whenever an earthquake occurs, it leads to release of energy, heat energy, sound energy, light energy, different forms of energy. If you consider most of them, they travel in a wave format. Similarly, energy released during an earthquake, that also travels in the form of a wave, and that is what is referred to as a seismic wave. Now here, I want you to understand a couple of aspects, or able to imagine few things. Can a foreshock be strong enough to cause significant damage? It can be. You can have a foreshock of 4 magnitude, 4.5 magnitude, 5 magnitude. That can also create a substantial amount of damage, right? So here, when we talk about seismic waves, sometimes during a volcanic eruption, you can experience an earthquake. So when you have a major volcanic eruption, as the magma tries to come out, earthquake will be observed. That is why in the region of Iceland, for the past couple of days, if you have not followed this news headline, search it online. This will become a part of current affairs. 2 days from now, I will have a lot of candidates coming to me with the curiosity that what has happened in Iceland. Or 1 week from now, a lot of you will come over that talk about the volcanic eruption which has happened in Iceland. So Iceland has experienced more than 800 minor earthquakes in the past 3 to 4 days. And why will Iceland experience earthquake? Because the molten materials are trying to come out. Volcanic eruption is going to happen. In the next few days, Iceland is going to experience a volcanic eruption. When, exactly what time, we don't know. But the occurrence of these earthquakes, around 800 of them, that is a precursor of that molten materials are trying to come out. Now, these events, sometimes what happens, for example, in certain areas, you will experience minor earthquakes. They keep on happening continuously. For example, as I told you, 800 such events have happened in the region of Iceland, all of minor intensity. They are referred to as earthquake swarms, right? They are referred to by the name earthquake swarms. These basically relate to multiple number of minor earthquakes experienced in the same region, same area, over a short duration of time. Okay. Now, here, you all would have basically heard, if not experienced earthquakes in your life. At least you would have heard about it. If you would have experienced earthquakes, a major one, you would always remember that experience in your life. You will never forget it. That is how horrendous and horrific it can be, where the ground, literally the ground underneath your feet, that starts to move, that starts to shake. Now, it is a very unstable feeling out there, right? You would have seen the videos where people immediately they fall on the ground, or they hug the ground, because they are so very disoriented. You don't know what is happening around you. The buildings are shaking and so on. Now, that shaking of the surface, why do we experience that? because of the energy which is released during the earthquake. Now, when we talk about the energy released during an earthquake, energy is released from where? From the region of the focus, isn't it? So we can say that the origin of the seismic waves is going to be the focus. But these seismic waves, you have a further classification of them. You have the classification as body waves and surface waves. Okay, you have the classification as body waves and surface waves. So what are these? So let us consider different conditions. Let us suppose this is the ground surface. You have the buildings in this region, right? Various different kind of, let's suppose, a semi-urban sprawl. Now here an earthquake has originated. Let's suppose that is your focus of the earthquake. Let's suppose that is the focus. Now, as an earthquake has occurred here, energy will be released. Now, energy, whenever energy travels, is it unidirectional or is it omnidirectional? In the sense that when energy is transmitted, does it travel in only a particular direction or does it travel uniformly all around? What is your understanding about how the energy is transmitted? Good. Multidirectional, omnidirectional, all directions, isn't it? Because when, let's suppose, you light a candle, it will release light energy, but it won't be the case that candle is releasing energy only in a certain area, right? If you put a speaker in the center of the room and you switch it on, then the sound will be heard all around. It won't be the case that you are sitting only in a particular area, only there you will be able to hear the sound. So energy is omnidirectional. It is multi-directional. It doesn't have a predefined direction associated. We give it direction with the help of deflectors, etc. We provide the direction to energy source, but always energy is omnidirectional. So here also, energy will be released. Now this energy will basically travel in all different directions, all different areas, isn't it? See, that is why sometimes very smart people, what about laser light? Laser light, my dear friend, you have the light energy is directed. Only then you have laser light which is generated. Do you think laser light, naturally you get a material out from nature, you keep it on table and laser light will be generated? The very reason why you have the generation of a laser, if you go into the depth of it, it is because of the multiple resonance and the reverberations of the light energy that you do in a certain direction, so as to reinforce that. Only then it becomes more energetic. Do that reading about laser light and then you talk about this comparison. But think about it, if in all seriousness, in all fairness, think about a candle, right? Or the sun, the source of light energy, or a bulb that you install. It will provide light in all direction unless and until you provide a direction to it. I hope you are able to gather that. I hope you are able to understand that. So energy will be released from the region of the focus. Now this energy will travel in all different directions. Let's suppose this is the focus that we are talking about. Let's suppose this is your focus. Okay, this is your surface. This is the focus that I am representing in the different image also. Now energy, as it transmits, it will move in all different direction, right? Now it will be moving in the form of waves, which are known as seismic waves, right? Now here, as this energy will travel through the interior body of the planet Earth, it will reach the surface in different areas. But earliest, it will reach the surface in this region. In this region, it will reach the surface immediately or immediately above it. That is where the energy waves will be able to hit the ground surface almost immediately. Right? Here, let's suppose this is your epicenter. So can we say that epicenter will experience these energy waves for the first time? Or immediately the region which will experience the energy waves will be, or seismic waves will be, the epicenter? Isn't it? Now, epicenter is what? Epicenter is a region on the portion of the ground surface itself. On the ground surface itself, you have the epicenter. So if I have, let's suppose, if I consider a region like this, let's suppose. Now, if the epicenter is here, this is where the epicenter is. Now, if this is the epicenter, basically, now, if this starts vibrating because of the energy waves received from the interior, if this portion starts to vibrate, its surrounding areas will also vibrate. This surrounding region will also vibrate. This surrounding region furthermore will also vibrate. The vibrations will spread over, just like how you have ripples in water. Just like that, if this is the epicenter, the vibrations will be felt all around it, isn't it? So, the energy waves which have been generated in the interior, they have generated their own set of disturbance on the surface. So, on the surface, now you have an energy which is being transmitted from the epicenter outwards. So, the farther you are from the epicenter, the impact will be lesser. Closer you are to the epicenter, impact will be quite significant, isn't it? So, can we think about the situation where the focus which is present in the interior, that is the source for the generation of these earthquakes. That is the source for the release of that energy. That energy travels through the body of the entirety of the planet. It disturbs the epicenter first. And then, suppose if this is the epicenter, if this starts to shake, the rest of the portion of the land will also shake as a result of it. Right? So, on the surface, you have generation of another wave-like pattern where energy gets transmitted. So, those are referred to as by the name body waves and the surface waves. So, when we talk about body waves, these are your body waves which travel through the interior of the planet, through the body structure of the planet. And then you have the surface waves, which basically they travel from the epicenter outwards on the surface itself. So the body waves, they disturb the surface and then they lead to the release of these surface waves or the generation of these surface waves. Okay. Now, here, yes, a region directly above the focus is epicenter. I agree. So here, when we talk about the seismic waves, so when an earthquake occurs, it releases waves of energy which are known as the seismic waves. It is like ripples created in water if you throw a stone. And based upon the medium that they travel in, they can be divided into body and the surface waves. Body waves travel through the interior of the planet. Surface waves get generated on the surface as the seismic waves or the body waves disturb the surface. I hope this is clear. So can I say that body waves, they originate at focus Can I also say that surface waves, they originate at epicenter, right? Surface waves won't be originating at the focus. Surface waves will be originating at the epicenter. Okay? Yes. Good. Now, let us study about these body waves furthermore. Now, when we talk about the body waves, at least for your general studies, you have to be concerned about only two types of body waves, right? That is the P wave and the S wave. Now, you have to understand that these waves will get generated when there is occurrence of an earthquake. Okay, whenever there is an occurrence of an earthquake, only then these body waves or these seismic waves will get generated. Does it mean that body waves will become surface waves as they reach the ground? No. Why will they become surface waves? What is a wave? Energy, as it is transmitted, it moves in the form of waves. So, if this is your ground surface, here is the focus, the body waves will reach here. They will disturb this. Now, as this gets disturbed, it will have its own amplitude, its own variations, its own vibrations. So it will have a generation of a different surface wave. Greater that you punch it, greater the wave which will hit the ground, greater will be the disturbance. Lesser intensity it will hit the ground, lesser will be the surface wave. Okay. It means body waves generated outward from focus in interior and surface waves generated through surfaces. Yes. So, body waves, they are released from focus whenever you experience an earthquake. That is when the body waves they get generated. Now, the energy released, it ends up disturbing the particles in different manner. Particles in terms of the solid, molten materials, all of them they are made up of molecules, atoms, atomic structure. So the particles they get disturbed when these waves they travel in different manner. And based upon how the particles get disturbed, you have the classification as P waves or primary waves and S waves. So let us take a look at the characteristic of these P waves and S waves. I'll provide you with a detailed chart or the differentiation also, right? So before that, let us consider P waves. First of all, it is of two types, P wave and S wave. Okay. Now, P wave. Now, let's suppose an earthquake has occurred with a focus here. Or let me use the horizontal image. Let's suppose you have an earthquake which has occurred with a focus here. And you have various different particles in this area. Okay, how many of you are attending the session with a book open in the sides? That let me see what he is teaching with that, in which page the book is there. Is it turning out to be helpful? Is it turning out to be helpful? Okay, then fair enough. No, I'm not talking about the Byju's book, any kind of book here. What I would rather suggest all of you is that try to pay utmost attention to the class sessions. Try to understand the class sessions, because what I am seeing as many of you in the type of questions also, that in the book this is written, you have said this. In the book this is written, you have said this. That creates so much amount of diversion in your mind itself, you won't be able to concentrate. So I'm all for reading all different kinds of books which are there, but immediately what I would suggest is try to pay attention here, because for example what we are going to talk about here, that is not explained in images in the book. So try to pay attention here. Revision you can do with the help of the book. Okay? Revision you can always do with the help of the book. But as of now, please try to pay attention. So, and Seema, this is for your question that in NCRT it is of three types, P, S, and L waves. So we will come to it. We will come to it. Have patience, my dear friend. In case NCRT has given something extra, try to follow it. But I'm sure you won't find that to be the case. Okay. Now, here, let's suppose this is the focus from where the energy is released. Now, in solid, all the particles, they are attached very close to each other always, isn't it? So let's suppose the particles are present here, 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 like this. Now, if this is your focus, this is the direction in which the wave has to travel. This is your direction of wave motion. Direction of wave motion. Now here, how do the particles behave that we represent them as P waves? Now, when this energy is released, each of these particles, they will start vibrating to and fro. Each of them, they will start vibrating to and fro. So what will you have is that the wave gets transmitted just like the sound waves do. If you observe the property, if you have observed the property of the sound waves, you have compression and then expansion. Then again compression, then again expansion. Right? Because all the particles, they are moving towards. So if the particles are placed like this, each of them, they start vibrating to and fro. Each of them, they start vibrating to and fro. So this particle will disturb the next one will disturb the adjacent one, and like that, the disturbance will be transmitted. Now, after some time, you might very well have a situation where you have these particles like this. Right? So that is where you find that by expansion or compression, the wave propagates forward. Now in this, the direction of particle motion, each of these particles, they are vibrating in the same direction as the direction of the wave propagation. The direction in which the wave has to move, the particles are vibrating in the same direction. So eventually, due to this, what happens is that P waves, they travel very fast. Right? Because the direction of the wave motion and the direction of the particle movement is the same. Direction of wave motion is the same as the direction of particle movement. Hence, P waves move very fast. Now, consider if we have the liquid medium. Now, in the liquid medium, the particles are very far away from each other, gaseous medium even further away from each other. It is in solid where they are the closest, liquid slightly far, gaseous even more further. So here, when we talk about, let's suppose the liquid medium. So here, let's suppose you have the particles which are far away. Now, if this is the focus and the energy is released, the particles, the first particle will vibrate like this. It will disturb the space of the second particle. So the second one will also vibrate. That will induce a vibration in the third one also. That will induce a vibration in the fourth one also. That would induce a vibration in the next one also. That would induce a vibration in the next one. And like that, eventually all will be disturbed, isn't it? So, because the direction of the particle movement is the same in which the wave has to move, that is why P waves are able to travel even through liquids and gaseous medium which are present in the interior of the planet. So, here it is because of this reason that P waves are able to travel through liquid and gaseous mediums. Now, then when the earthquake occurs, you have this kind of a movement which we refer to as the P wave. You have another kind of disturbance for the particles as well, and that is what we refer to as the S waves. Now, these S waves, basically, if let's suppose here you have the focus, if you have the particles arranged like this, this is the direction of the wave motion. Okay. So here what you will observe that the particles are getting disturbed in a different manner. The particles are getting disturbed perpendicular to the direction of the wave motion. So eventually the wave that will be generated will have a characteristic somewhat like this, where each of these particles, they are moving almost perpendicular to the direction of the wave motion. Okay, this is your direction of the wave motion and this is the movement of the particles, right? So here you will observe that the direction of the wave motion, direction of wave motion is perpendicular to the direction of particle movement. Now, consider something very logically. In the case of the P waves, the particles are moving like this as the wave is pushing forward. In the case of the S waves, the particles are moving like this. The next particle will be disturbed, then the next one will be disturbed, then the next one will be disturbed, and that is how the wave is moving forward. So, where is it that the wave will travel faster? In which case will you have a faster movement? Is it the case of the P wave or the S wave? What do you think? Good. Always the case of the P wave, right? So P waves, that is why, will always travel at a much faster speed as compared to S wave. And this particular property also means that when you have, let's suppose, a liquid or a gaseous medium, when you have the particles which are far away from each other, particles which are far away from each other. Now, if you will observe a disturbance here, let's suppose, now maybe the second one might get disturbed ever so slightly, but not more than that. That means maybe the third one might get disturbed a bit, but not more than that, right? So here, eventually that disturbance will die down. Unlike the P wave, where the first disturbance will hit the second particle, the second disturbance will hit the third particle. Here you don't have the case. It will die down. Right, the wave in itself will die down. That is why S waves are unable to travel through liquid and gases. Because of this reason itself, S waves are unable to travel through liquids and gases. So you see that the P waves, they travel faster. The P waves, they travel quickly. Now, this is a property which has been used in order to develop early warning systems. For example, regions such as Japan, which experience earthquakes with very great frequency. Very frequently, you will hear about Japan experiencing earthquake of magnitude 7, 7.5, and so on and so forth. Right. Now, in Japan, you also have very tall buildings. Lot of devastation, destruction used to happen till they started building the earthquake resistant buildings or the earthquake resilient buildings. Now Japan had or also has one of the most developed fast train networks in the world, the bullet train network. Now, because of these earthquakes, the bullet train network also used to experience damages. Because, as imagine a fast train is moving and an earthquake has occurred, obviously the train will get upthrown, it will get derailed. And it has happened previously, killing a lot of people. So, Japan did this thing where they developed the early detection, early warning systems. So, what these systems now, these systems are deployed all over in the region of Japan. Now, how these systems work is on a very simple fundamental that they are able to detect the P waves, right? Now, these P waves, because they travel very fast, they are able to reach before the main or the entire aspect of the body waves when they hit the surface and the surface waves get generated. So, around 1 minute or a couple of minutes before that, or maybe even 2 to 3 minutes before that, you experience the P waves first, and then the main earthquake along with all the other type of body waves they hit the surface. So that is used as an alarm. So these detectors, they immediately detect those P waves, they ring that alarm. Now you have a time window of 1 to 2 minutes or 2 to 4 minutes at max. Now you might think, what will happen in 4 minutes? I have to do so many things in life. I have to get in touch with my old friends, etc. What will happen? 4 minutes is more than sufficient, or even 1 minute is more than sufficient to save yourself from disaster in case you have some other escape area. For example, if you are in a building, you will take a shelter somewhere near the pillar region or under a table. If you are in an open space, you will take a shelter somewhere. Or if in the case of the bullet train network and the bullet train technology, as soon as these alarms they go off, immediately emergency brakes are applied through the system. All the trains, they come to a screeching halt wherever they are, so that within a minute, when the main earthquake strikes, the trains are in stable position, static position. That has minimized the damage. Okay, so this is what? This is nothing but disaster management. That is why once you are aware about how these disasters they occur, obviously management part of it will be the easier aspect. Okay, so here in the case of the S waves, you will observe this is the kind of a movement of the particles. In the case of the P waves, you will observe compression, expansion. That will be the case. Okay. So here is the differentiator part. For in a tabulated manner, P waves are the first waves to hit the Earth's surface. S waves, they arrive after the P waves. And the P waves, they travel in the speed range of around 4.5 to 13 kilometer per second. You have many different classifications of P wave also, right? P star S, PG, right? PS star. Different types of P waves, different types of S waves are also there, different types of body waves. But for your GS, you don't have to get concerned with it. You just think about it that the P waves, their variation is between 4.5 to 13 kilometer per second. Now, S waves, they are almost 1.7 times slower than the P waves. So they arrive after the P waves. And this is where how the movement of the P waves they happen. The waves travel in a linear direction similar to sound waves. similar to sound waves. And S waves, they travel in a manner similar to light waves. Right? Similar to the case of light waves. So the P waves, they can travel through solid, liquid, and gas, and the S waves, they will be able to travel only through the solids. Now, both these P and S waves, or the body waves, the work that they carry out is shaking of the Earth's surface. They will shake up the Earth's surface. Right? Now, that can cause some damage in that region. But the major damage, the main damage, is created as they hit the surface. They will generate a different set of wave on the surface, which are regarded as the surface waves. Okay, so that is where we refer to them as the surface waves. So surface waves are those waves that travel on the surface of the earth from the region of epicenter outwards. So they travel from epicenter outwards. Okay, now all the destruction that you observe getting created or getting caused by the surface or by during an earthquake is majorly caused by the surface waves themselves and the surface wave phenomena. Okay, so the destruction caused by earthquakes is primarily done by these waves. Now, in many books, in majority of the books for general studies, you will find the surface waves being named as L waves, and that is when they are done with it. And in fact, for your general studies, you don't need to go into further detail also. But even that surface, for example, in the case of the body waves, we have seen that the particles, they can get disturbed in this manner or in another manner. Similarly, the surface can shake in a horizontal fashion, right? Where one portion will shake like this, the other portion will then have a shaking like this. So you have a horizontal shaking, or it can have a kind of a vertical undulation or a development of a vertical wave like pattern. So the surface can get disturbed in either of those manners. And in either of those manners, that disturbance travels epicenter outwards. Closer to you are to the epicenter, greater is the damage. Further away that you go from epicenter, lesser is the damage. Right? For example, the Bhuj earthquake in Gujarat, which occurred on 26th of January. By the way, those of you who are not aware, and in fact, many of you would not even have been born at that point of time, or would have been, if born, very, very young at that point of time. Now, Bhuj earthquake occurred on Republic Day. And at the time, Republic Day parade was going on in Delhi. Now, the surface waves generated reached the region of Delhi as well. So think about the distance that they travel. Nepal Kathmandu earthquake, which occurred in 2015. The surface waves generated traveled all the way to the region around Delhi also. Right, some portion of the body waves also hit that, but the surface waves also traveled. Surface waves, in fact, traveled during the Nepal earthquake to the adjoining areas of Bihar, Uttar Pradesh, and that caused a lot of damage in that area also. Okay, now based upon how they will disturb the ground, they are further classified into love waves and Rayleigh waves. Okay, so the speed of it, P wave is the fastest, then comes the S waves, then comes the love waves, and then comes the Rayleigh waves. Now, this love wave and Rayleigh wave, purely the classification based upon what kind of vibration that you experience on the ground surface. If the ground surface starts vibrating almost horizontally, it is known as a love wave. And if it moves in a kind of a vertical undulation wave like pattern, that is what is referred to as a Rayleigh wave. That's it. This will be only relevant for your prelims. Okay. Okay, I have a couple of questions. Um, Shazia, P waves also travel both solid and liquid medium and faster in dense medium, while S waves travel only in solid medium and cannot travel in outer curvature. Yes, that is true, Shazia. Biswajit, are those waves able to travel quickly through solid medium? Yes, they are. Shyam, what will be the radius of focus? I mean, the point where the energy released at the interior is that small, very small area. It is that zone of friction which is being overcome. It will be generally very small point. Saurabh, in India, early detection of earthquake natural disaster management team, alarm smartphone. Okay, for early detection, India is sending alarm notification on our Android iOS application. Are they measuring the P waves? Generally, all the early detection devices will end up measuring the P waves. Can surface waves travel through the mediums? On the surface, they don't have to encounter different mediums. On the surface, they have to encounter only solid. Okay. Okay, that brings me to another kind of misconception which does prevail significantly. So, here, for example, if I consider a region like this, or let's not draw a bathtub out of it. So, let's suppose this is your ocean. Okay. Now, if I ask you, which will be considered as a surface? Will A be considered as a surface or will B be considered as a surface? What do you think? Okay. So this is where the misconception lies. Okay. Understand, water is not considered as a surface of Earth, right? Because if let's suppose the water level reduces or increases, will we say that the surface of planet Earth has changed? No. Always, for all practical purposes, B will be considered as the surface. Always. B is the surface, and the surface waves will be generated from here. Okay. So you won't have a condition where the surface waves have to travel through different medium. They end up traveling to the same medium. Subramania, in any case that P and S wave is helpful for determining core region, yes, that is true. Surface wave and S wave both are transverse wave in nature. Not necessarily, because Chandrajyoti, we have seen that even surface waves have a subclassification, right? Both of them move in different direction. Which is used to develop early warning system, P wave detection system. Akshay, Anjali, in Baiju's book, speed range of P wave is 1.5. Okay, consider the portion given in the PPT. And which wave is faster, surface wave or P wave? P wave is faster. That is where, Sham, I had given the entire chronology. P is the fastest, then comes the S, then comes the love, and then comes the relay. Okay. Then where this love and relay wave formed in any earthquake before, Shabir? Whenever an earthquake occurs, you will have the shaking of the surface. It is there on the surface that you experience these waves generated. So earthquakes can occur both on continental crust and oceanic crust. Obviously, yes. Oceanic convergence, we have seen that an earthquake is generated in the oceanic crust. Okay. Then, right. Shallow love wave is oftentimes more destructive, yes. How to prevent from earthquake? See, you cannot stop earthquake from happening, Vishwas. So what you can actually end up doing is build earthquake resilient buildings, earthquake resilient infrastructure, have those emergency response systems, and have the emergency evacuation systems in place, early detection systems in place. That is all that you can do, right? Okay. Why waves don't travel in shadow zone? let us talk about shadow zone and then we will move forward. You should take the address. Okay. So that is basically the aspect of these body waves. Now we come to the concept of shadow zones. So, what do we understand by shadow zones? So, when we say a shadow zone, before that, you need to understand the characteristic of movement of these body waves. Again, body waves are what? Body waves basically are energy waves which travel. So, energy waves, when they encounter materials of different density, will they move in the straight line or will they experience a deviation? They will always experience a deviation, isn't it? So, for example, if you consider this, you would have, I don't know if you would have studied it earlier or not. But generally, the fundamental is that if you would have observed the light wave, when that hits the glass, it basically ends up getting deflected. And again, after glass, it hits the air. Again, it gets deflected, isn't it? So, based upon this, we can have a conclusion that whenever you have energy which travels through materials of different densities, different mediums, etc., they end up getting deviated. They won't travel in a straight line fashion. They will end up getting deviated, right? So I hope I can write that conclusion. I hope that won't be a point which is debatable. Energy, when travels through materials of different density, experiences a deviation. Now, with that concept, let us consider the interior of planet Earth. Now, here, if I consider a region, let's suppose here, let me name this as A. And if I consider a region here, B, both of them will have different density. If I consider the region here, C, all three of them will have different density. If I consider a region here, D, it will have a different density. If I consider a region here, it will have a different density. If I consider a region here, different density. So, in the interior of the planet, in the interior structure of the planet Earth, you experience or you basically observe materials of different and varying densities. Now, let's suppose the focus of an earthquake is here. Let's suppose this is your focus. Now, here, as the earthquake is experienced, as the earthquake basically happens, so here you will have the energy waves which will get transmitted, but the body waves, will they be traveling in the same, in the straight path? Obviously not. They will be deviating. Initially they will hit the epicenter almost immediately, then they will be deviating. They will have a bend, right? Now, because of this bend, you will have certain areas where these waves won't be observed. With the help of the instruments that are deployed across the planet, that is how we are able to observe or measure these earthquakes. That is why, even if an earthquake occurs in the region of Nepal, you would have heard that it is the US government which comes up with a notification that, as per our instrumental readings, the earthquake of magnitude 7.5 has occurred in the region of Nepal. So you basically have seismographs and instruments installed across the world. So that is how you measure how these seismic waves they travel through the interior. So there will be certain areas due to the bending of the waves which won't experience these body waves. Okay, so though those areas are known as shadow zones. So as the seismic waves bend as they travel through the interior. Means what? It means there are some places where these waves are unable to reach due to the deviation. The deviation. Those are known as shadow zones of the seismic waves. Okay. So those are known as the shadow zones. So let us take a look at the image and let us try to understand it. So for example, let us consider a situation where an earthquake has occurred here in this area. Now both P and S wave will be generated. So let us study the characteristic of the P wave. Now observe that the P wave will bend. It won't go straight, it will bend as it encounters materials of varying density. Now, this P wave will encounter the molten portion of outer core. We have seen that the P waves have the ability to move through even the solid, liquid, and all the gaseous medium as well. P waves have the ability to travel through that. So these P waves, they will be traveling through the region of outer core. And then when they enter the region of the inner core, they encounter a solid. Suddenly their speed increases. They move further. Again, they will encounter different materials and will reach here. They will reach here. But if you observe these areas, here you don't detect any P waves at all. Isn't it? No P waves are detected here. Why? Because the bending is such that the P waves are unable to reach here. Isn't it? The bending created is such that the P waves are not detected here. So that is the shadow zone or the P wave shadow zone for an earthquake which has occurred there. Now, what about the S waves? We know that S waves can travel only through solid. They cannot travel through liquid. So S waves here, as soon as they encounter the molten outer core, S waves won't be able to travel any further. And here they are bending, so maximum they can reach here. So in the entirety of the region here, no direct S waves are able to reach. No S waves are detected here. So that is the shadow zone of the S wave. Right? So these are your shadow zones. So for example, suppose if you consider a situation or a scenario where if this is the planet, let's suppose, and here an earthquake has occurred. Now, from here also, the P waves as they will travel in all different direction, epicenter is where it will reach first, and then they will bend. Isn't it? Then they will bend. So for the P waves, the shadow zone is generally around 105 to 145 degrees on both sides from the region of the focus. Whereas for the S waves, the shadow zone is much larger. When we talk about the S waves, here the shadow zone created is much, much larger. Why? Because it is unable to travel through the molten outer core at all. So that is why here we talk about it that shadow zone for the S waves. Shadow zones for S waves are much larger as compared to P waves, right? And why is that the case? Because this is because the S waves are unable to travel through the liquid medium, outer core, right? Hence, they are not detected over a larger area. Okay, so let me repeat the entire concept once again, very briefly, so that you are able to fully comprehend it. What is the concept of a shadow zone? I hope we understand the meaning of shadow. I hope we understand the meaning of zone. What is a shadow zone? So, wherever an earthquake occurs, maybe an earthquake has occurred in Chile, maybe an earthquake has occurred in the region of Nepal. And listen to the next few moments very carefully before you keep on typing questions. Listen to this carefully. So, wherever an earthquake has occurred, there will be generation of body waves. Now, these body waves, they will travel through the interior. But how will the body waves travel? Ideally, if you think about a computer, a kind of an image which comes to your mind, you will think that the body waves will travel like this through the interior. But that is not the case. Why? Because these body waves, they are after all energy, right? Now, these body waves, they will never travel in a straight line. They will not travel in a straight path. Why? Because energy, when travels through materials of different densities, experiences a deviation. We have seen that with the help of light, refraction of light, etc. So, whenever energy travels through mediums of different densities, it will experience a deviation. So, as we consider the interior of the planet, different regions have varying densities. So that is why the waves, they will end up bending over. They will have a curved path. Now, because of that curved path, obviously, you can think about it. Till where will you have this curved path? Till where? Beyond this, you cannot have this, right? You cannot have a condition like this. It continues to go on like this. No, it cannot happen like this. So there is a limitation. So there will be certain areas where these P waves and S waves, they are not detected because of the path that they choose to travel through. So those regions where the P waves and S waves are not detected, they are known as the shadow zones. Okay. So as the seismic waves bend as they travel through the interior, right? We know this for a fact that seismic waves, they bend as they travel through the interior, as they encounter materials of different densities. Now that means there are some places where these waves are unable to reach due to the deviation in their path. Now those areas where they are unable to reach, they are known as shadow zones. Okay, so those areas where P waves are not detected, P wave shadow zone. Those areas where S waves won't be detected, S wave shadow zone. Now, if I ask you a question, shadow zones, will they be permanent? That the region of Chile is a shadow zone, or the region of the Pacific is a shadow zone, or will that shadow zone be variable? What do you think? Very good. It will be variable. Depending upon where the focus has been, shadow zone will be created accordingly. 105 to 145 degrees on both sides in the case of P waves, 105 degrees on either sides in the case of S waves. So that is how you have the shadow zone. By the way, as these waves, they travel through the interior, not only will they encounter materials of different densities, they will encounter materials arranged in different patterns also, which will alter the speed of these waves. Now, this information is used to study the interior structure, internal structure of planet Earth. Remember, we talked about the sources of information which give us an idea about the interior of planet. These body waves, they are important. Why? Because we know the speed of the P wave and S wave, roughly about. We know the focus. And let's suppose you have deployed a ship here to measure with the help of the instruments, you measure it out. So you know the time taken for the P waves to travel. Maybe you will be able to detect the path also. So with that help itself, you are able to basically detect that which is the region through which the P waves or the S waves would have traveled and what are the materials that they would have encountered. It is by this particular deduction that one is able to deduce that these minerals might be present in the region of outer core, these minerals might be present in the region of the mantle, these minerals are dominant in the region of inner core. It is based upon the study of these seismic waves, because we know the density of different materials. We know that if P waves and S waves travel, what kind of deviation will be experienced. Accordingly, we extrapolate it. In fact, one of the geographers, Lehman, he was the first one. When he was studying these earthquakes, he was the first one who observed that these P waves, as they travel through the region of the core in the central portion, their speed suddenly appears to accelerate. They suddenly appear to accelerate in their speed. And as they accelerate, means what? That there must be a solid in the region in the central portion of core. And with that, he came upon the conclusion that inner core is in solid state. That is why the discontinuity between outer and inner core, that is also referred to as the Lehman discontinuity. So this is used to study the interior of the earth structure also. Okay. Now, here, when we talk of asthenosphere is not solid. So asthenosphere is not liquid also. Asthenosphere is semi-solid, semi-molten state, plasticky state. S waves will travel through it. It won't travel through complete molten liquid. Okay? Right. See, all of you, when you ask the question, you always attach that, please answer this question urgently, or please answer me. Please understand. I will take the answers. I will take the questions. Let us cover some of the syllabus first. Many of the portions will be self-clarified. After a point of time, many of the portions you will automatically find it to be much easier. Okay? So I will take up the questions at the end. Now here, when we talk about another event which is induced or which is triggered by an earthquake, that is basically a tsunami. Now, tsunami is a Japanese word which refers to giant wave. Now, how are tsunamis generated? Tsunamis are generated whenever there is a massive earthquake which has occurred underwater, under the oceanic region. Whenever is generated, whenever there is an occurrence of a strong underwater earthquake. Now, again, I will take you back to the similar image that we had observed first. Basically, let's suppose this is your oceanic region. Let's suppose this is the continental area. Okay. Let's suppose here you have the presence of water. In the ocean. Okay. This is your ocean. Now, if there is an earthquake with a focus here, earthquake with a focus here, now this will disturb the earth's surface, right? So this will disturb the surface here. It will hit the surface. This will be your epicenter, isn't it? This will epicenter will vibrate first of all. It will get disturbed, and then the surface waves will get generated all across here. Now, as the base is disturbed, what will happen to the water? For example, if you have a bucket or if you have a mug of water in your hand, let's suppose you don't touch the surface, but you hit the base of the mug. What will happen? Water will spill over because the entire water column will get disturbed. So, here also, when you have the base of the ocean floor, in fact, the ocean floor in itself getting disturbed, what will happen? You will have that disturbance getting transmitted upwards, right? You will have the generation of a wave, a large disturbance overall. Now, this large disturbance will travel outwards in all different directions. In all different directions, it will travel very quickly, just like from the central point, a ripple of water travels outwards. In a similar manner, this will also be traveling upwards, outwards rather, and they will hit the coastline. And across the coastline, you experience what is a tsunami. Right. So majority of the tsunamis that we have experienced, for example, I will give you certain examples. Now, one of the tsunami that all of us we dreadfully remember is that of 26th December 2004. The tsunami which occurred across the region of the Indian Ocean and the region of basically Eastern Indian Ocean. Now, that tsunami, it devastated the region of Andaman Nicobar, many of the islands. Sri Lanka was completely destroyed. Maldives, to a significant extent, was completely destroyed. Our eastern coastline was destroyed. And Chennai and the adjoining areas experienced that destruction. Region of Indonesia experienced that destruction. Now, this tsunami was triggered by what? It was triggered by an earthquake, by an earthquake near Sumatra. Very good, Shalu. Near Sumatra with a magnitude close to around 8. And that had so much amount of destruction potential. It generated a tsunami. Then another famous case was of 2011, and particularly March 2011. Now, Japan is again at a point of convergence, the convergence zone where the Pacific plate is basically subducting underneath. So even in the region of Japan, you have frequent earthquakes. So there also, to the east of Japan, you had an earthquake of magnitude 8 plus. Now that generated a tsunami, which created the nuclear disaster in Japan, where the Fukushima nuclear plant experienced leakages, right? And you had substantial amount of damage. Then in the month of January 22, last year, okay, around 15th of January 2022, you had a massive volcanic eruption occurring in the region of southern Pacific around Tonga Islands. Now, that volcanic eruption is considered to be one of the strongest volcanic eruption that we have experienced in this century, after the Pinatubo eruption in 1991. So that eruption was so very massive that many areas, the tsunami was generated in that region. And understand, where is Tonga Island? In closer to Australia? The tsunami generated reached all the way till South American coastline, claimed 2 lives in the south region of South America. So that is how the tsunamis travel or are generated whenever you have that underwater disturbance which happens. Okay, I hope that is understood. You had a very massive volcanic eruption which occurred in the 1880s. That was the Krakatau volcanic eruption. Now, even the Krakatau volcanic eruption created a damage, right? Created a damage which was so huge that basically it generated a tsunami, which again hit the Indian coastline, Andaman, Nicobar, Java, Sumatra, all of these. So, even volcanoes, if they are very strong, volcanic eruption, that will also bring about shaking of the surface. So, that can also generate a tsunami. As long or whenever the base of the ocean, let's suppose this is the base, there is subduction going on, there is an earthquake generated here, it will disturb the surface, that will disturb the water, okay, and a tsunami is generated. Now we come to the last topic of the day, and that is the geographical distribution of earthquake, and that is the areas where we experience earthquakes. So where do we experience earthquake? Is it random that today God is angry on that region, so that region will experience earthquakes? Like you observe on social media, various different things that are floated on the social media, that you have too many sinners there, that is why earthquake. No, basically, if you consider the entire world, there are certain areas. I want you to observe this image. Now, mostly all the earthquakes that you will be experienced at some or the other plate boundaries. Okay, it is across these plate boundaries where there will be some movement which will be happening in the lithospheric region. It is that lithospheric movement which experiences that force of resistance, which force of resistance is being overcome, and shaking of the earth's surface is experienced, isn't it? So generally, and this image, if you observe it carefully, you have the demarcation as the different plates also. Generally, this is an image that you can always utilize for your understanding. You won't find in the books also. So observe, where have the earthquakes been dominated in? So there are two regions where you will find great dominance of earthquakes. First is the Circum-Pacific Ring of Fire. This is the region of Tonga, guys, by the way. Those of you who are not aware, this is the region of Tonga Islands, where you had the one of the most massive earthquakes in the past decade or so. So the entire Circum-Pacific Ring of Fire, very massive and very frequent earthquakes. And the second region is here in the area of the Mediterranean Himalayan region. In these areas, you experience high frequency of earthquakes, very high frequency of earthquakes. Yes, this also continues in the region of Java, Sumatra, Indonesia, which is again a resultant of the disturbance in the Pacific plate itself. So overall, can we say that earthquakes are predominant in the region of the plate boundaries and the plate margins? We can say that, isn't it? So global distribution of earthquakes in areas of plate boundaries. Okay, now here different plate boundaries will have the earthquakes. So when you have convergent and transform plate boundaries, convergent and transform, strong or high magnitude earthquakes, high magnitude earthquakes are observed. And when you consider divergent plate boundaries, you will have low magnitude earthquakes which are experienced. Okay, so overall, earthquakes, they are experienced in areas where the crust is weaker. So you can basically summarize that they are concentrated in two major belts. So If let's suppose we consider those belts, circum-Pacific earthquake belt, because there's convergence or transfer movement happening in all region around the Pacific, and the Mediterranean Asia earthquake belt, which is also referred to as the Alpide belt. Now here also convergence is happening. In the case of the Himalayan region, continental convergence. In the case of the Mediterranean region, convergence is happening where the Mediterranean Sea is being subsumed. As the land masses, they will collide, the Mediterranean Sea is being subsumed. So there also you will have these earthquakes. Okay, so that is where you experience the occurrence of these earthquakes. So if a question is asked, and a question is frequently asked from this area in the mains examination, both for your general studies as well as for the optional, discuss the global distribution of earthquake. So what do you write? So in that question, the introduction that you will write, understand the pattern of it. I'm not going to dictate here. We will discuss that in detail later on. I just want you to understand the pattern of answer writing here. So in the introduction, you should write what an earthquake is. So earthquakes are basically the shaking of the Earth's surface experienced due to release of energy from the interior as the lithospheric regions they try to move with respect to each other, or as the interior portion experiences any movement. The shaking of the Earth's surface is known as earthquake. Whichever kind of definition that you can consider, one liner definition you have to write so that you are following up straight from the question. And then earthquakes globally occur in various different paths. Now, the distribution of these earthquakes can be concentrated or can be thought about to be distributed or divided based upon certain zones. You can also write that the earthquakes are mostly observed in the regions where the crust or the lithospheric region is weaker and there's a comparable movement with respect to each other. So, along the plate margins, be it the convergent, divergent, or transform plate margins, we experience the earthquakes. You can say that across the convergent and transform plates, we experience massive earthquakes, whereas across divergent plates, we experience minor earthquakes. Then you can talk about the zonation of it, the Mediterranean, Himalayan, Alpide belt, and the circum-Pacific ring of fire. You talk about the reasons very briefly, the why the earthquake occurs in these areas, draw the rough images of continental convergence or oceanic continental convergence so that to indicate where the earthquake occurs. And then eventually after that, talk about the fact that earthquakes are not only restricted to these plate boundaries, but even across regions of divergence, such as the mid Atlantic ridge, right? The mid Atlantic ridge, if you consider, then the other mid oceanic ridges, the East African Rift Valley. So, in all these areas, also earthquakes are overall experienced. So, that is what you have to highlight and summarize in your answer. Okay? I hope that is understood, right? Now, that is where we'll end the session here for today. And tomorrow, we will continue from this region further ahead. And we will talk about the earthquake zones of India, the human induced or anthropogenically induced seismicity. We will be talking about the various other aspects of it and volcanic eruptions and the landforms created, but we'll talk about tomorrow. Okay, so I hope today's session was helpful. Today's session was understandable, and frequently I see a lot of suggestions coming in about what to do in the session. Just ensure at your end you are able to understand what is being taught, more than sufficient. Okay, let us take a few questions now. Uh, how can an earthquake occur in divergent movement? Biswajit, basically, as in the divergent movement, the magmatic material tries to come out. So that also sometimes involves the magmatic material hitting the Earth's surface, inducing some shaking. So there also minor earthquakes can be observed. Now, Atharv, as you told, maximum focus point can be 700 kilometer in the Earth, which is asthenosphere or mantle. Then how shadow zone can be formed when seismic energy is not traveling from the core? Atharv, my dear friend, why should the seismic energy travel through the region of the core? If you think about it, let's suppose you are saying that an earthquake has occurred, if we consider the deep focus earthquakes, maybe at a depth of 400 kilometers in the region of the mantle. There also, the body waves will travel just like that. The body waves will be traveling just like that. Right. So the shadow zone will be created accordingly. Some portion will travel through the region of the core also. Okay. Earthquake is never generated at the region of the core. So I don't think where the problem is. Uh, Atharv, is that understood? Manish, uh, what is the difference between natural and artificial waves? What do you mean by artificial waves here, Manish? Does earthquake happen due to plate movement also? Vishal, yes. And why waves bend? Waves, they bend as they travel through mediums of different density. That is why they will bend. Because as you observed in the case of the light also, they go for refraction, they bend. So as they encounter materials of different densities, they will invariably bend. Okay, Vishwas, thank you. Considered. Naveen, transform plate boundaries, basically, Naveen, when the plates, they move parallel to each other, that is a transform plate. So if you consider a top view section of a plate A, B, C, it is not on top of each other. So don't think about that it is on top of each other, right? Let's suppose there's a convection current underneath them. A is moving in this direction, B is moving in this direction. Let's suppose here you have another one, that is D. C is moving in this direction, D is moving in other direction. So B and C, they are neither moving towards or away from each other, but their movement is driven by the convection current. They are moving parallel to each other. So it is a transform movement. Okay. Right. Manish, remind me about that tomorrow. We'll talk about it. I'll show you about how it appears to look like. And human induced earthquake, Satyam will discuss tomorrow. Will I be correct to say that during volcanic underwater eruption, it shakes the water and also the cool magma takes the place of existing water, which splashes the water on the nearby surface? But it is so very slow that the underwater volcanic eruption generally is not very explosive. It is explosive, but not to that extent. So that is why you won't have much of a splashing around. But yes, the logic is correct. Okay. Yashwant, ideally advisable to attend the live sessions, and for revision, do take a look at the recorded sessions. Certain areas are mentioned in slightly greater detail in the recorded sessions. Okay. Yes, Himani, that is correct. It varies. Dhyan, it varies. When the P waves travel through the core, it varies. In the region of outer core, inner core, the speed is different. In the inner core, it speeds up around 13, 14 kilometer per second. Right. There are some direct questions which we can write maybe 120 words, but not more. If the question will give for 150 words, will it lead to negative marks? Generally, people don't fall short of words. Generally, when your content gets enriched, you won't fall short on words. Don't worry about it. And Shreya's, geomorphic process are we going to study after volcanic? Which geomorphic process? Which geomorphic process are we referring to, Shreyas? All this that we are talking about the geomorphic processes which are happening. Okay. No. So, Ziba, it will create a tsunami only when there is shaking of the ground surface. Not all the volcanic eruptions will lead to the shaking of the ground surface. Only few of them will lead to earthquakes. So, earthquakes will have to happen for the generation of tsunamis. Okay. Exogenic we will study in the coming classes, maybe tomorrow. Right? So that is where we'll end the session here today. We meet again tomorrow and we continue furthermore. This Saturday again, because Monday we had cancelled the class. So Saturday we will have a session, a compensatory session for that. So this is just a prior intimation for you guys. You will receive a notification by your mail also. You will get that notification also. So tomorrow we meet. Till that point of time, do take care of yourself. Goodbye. Thank you.